Good morning. I'm going to start off with the Karakia, mihi to the atua, to the local iwi, and to those who have passed. And then I'll hand it over to Barry to officially welcome everybody here. Whakataka te hau ki te uru, whakataka te hau ki te tunga. Kia makinakina ki uta, kia mataratara ki tai. Kia hia ka ana te atukura, e tio, e hoka, e hauhu, te hei Māori ora. Te atua e runga rawa, nāna nei ngā mea katoa, nāna te kupu tūtahi, nāna te kupu whakamutunga. Ki te hau kāinga, ngāti tō rangatia, taranaki, whānau, tēnā koutou, ki a rātou kua wehe ki te pō moi mai rā rātou, moi mai rā. Rātou ki a rātou, tātou, tia tātou, tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you. Over to you, Barry.
Thank you, Peter, and welcome everyone. I'm Barry Borman, Chair of PHONZ, and we're delighted to have you all here today for our third online conference. As you've seen from the program, we've got a impressive national and international experts dealing with topics that are of vital importance to health intelligence. So once again, on behalf of the PHONZ committee, thank you for joining us. We really do appreciate your support and encouragement for PHONZ. It's my great pleasure now to hand over to Chris, who's in the UK, to chair the first session.
Thanks, Barry. Coming at you all from a not so sunny and a not so dry UK this evening. We have a very interesting presenter to kick off with this evening, and he's somebody probably you've heard of from his authorship of Bad Science, Bad Pharma, and I think you'll find it's a little bit more complicated. And his years as a journalist, a science journalist for the Guardian newspaper. So Professor Goldacre has kind of changed almost careers, and he's become a huge champion of health sector data analysts in the UK. As a professor at Oxford University, he's established the Bennett Institute of Applied Data Science. And in 2022, he was asked by the UK government to undertake a report, since become the Goldacre Review, but I think it was originally called Better, Broader, Safer, using health data for research and analysis. It was to go with the new strategic plan for NHS data use. And what Ben's really done in that, he's going to talk in his recording to us this morning about not just data and how we can use it safely and how we can share it, and in particularly in small places like New Zealand, but even in England, it's pretty easy to use it poorly and insecurely. And they've come up with some open data sharing methods, which are just revolutionary as far as the UK is concerned. But he's going to speak not just to those techniques and to the strategy. He's going to talk to analysts directly about some of the problems that we're having in the UK. And I think you'll see that they're probably the same problems that you're having in New Zealand at the moment. All right, without further ado, Patrick.
Roger that. Share and
Me, and I hope you can forgive this rather lo-fi way of recording a lecture from a very long way away. It's very good of you to have me. I should say I feel a profound sense of compatriotism with the people of New Zealand. I am the proud holder of an Australian passport. I just have to put on this ridiculous accent to be accepted in polite British society. I'm also a synthesizer geek, and I'm a big fan of the Synthstrom Deluge, which is a New Zealand-made synthesizer, sampler and sequencer with very interesting design features. And design features, design principles, ways of creating systems that then facilitate good productive activity is what I'm going to talk about today, and it is my preoccupation. I'm a data scientist, I suppose, now, previously a doctor working in psychiatry and increasingly now in public health and epidemiology, and I run an organisation called the Bennett Institute at the University of Oxford. And we are slightly different to other organisations because we do slightly different work to other academic groups. First of all, we produce, give me one moment, First of all, we produce research papers like every other research group does, but we also produce practical data science for the NHS, looking at variation in clinical activity and outcomes to try and optimise the safety, quality and cost effectiveness of care. A thing that was previously fashionable for university researchers to do and is currently in the UK less fashionable, and that will shortly be reversed. Secondly, we make our own papers and reports and dashboards, but we also build data infrastructure tools that everybody can use, and I'll walk through a few examples of that. But then lastly, we also do policy work. So I'll talk a little bit about the report that I did for Secretary of State for Health and Social Care in England, in which we talk about the need for trusted research environments instead of data dissemination in order to protect patients' privacy. Talk about the power of modern open approaches to computational data science, sharing your code as you go, not as a political good, but as a practical means to improve the quality, transparency, reproducibility and efficiency and reusability of your code and all of your work. And lastly, I talked about changes that, in my view, are necessary to update and strengthen the community of NHS analysts in England, who are a group of really unknown number. There's estimated to be about 10,000 people working in data analysis for the NHS, and they are something of a lost tribe. So I wrote a whole section in the review about how to address that challenge. So what I'd like to do is talk a little bit about some of the work that I've done on open prescribing and open safely in order to earn your attention, I don't want to say respect, to convince you that I know what I'm talking about, and then I'll talk about some other work that we did in the review on NHS analysts. So lastly, as I said, we make our own papers and dashboards, but we also build tools for everybody, and to do that kind of work means that we do more than research, and that means that we need more than just researchers. So we have software developers and policy wonks when we work on building software tools and doing work in policy. So that's a little picture of what we look like. Okay, so data. There's no need to really restate it here for you because you know all of this, but data is how we find out which drugs work, it's how we spot side effects, it's how we spot problems in local health services and surgeons with room to improve, it's how we plan services and optimize care. But, and it's a big but, data doesn't do that on its own. Data needs to be checked. You need to do data quality checks. You need to prepare it, reshape it, curate it. Then it needs to be housed and managed securely in places where people can access it, but whilst protecting the privacy of the patients who created the underlying records with their lived experiences. Then the data needs to be analysed by people who have both data science skills of a generic nature and also domain knowledge about how health data works and what the pitfalls and opportunities are. Then that data needs to be communicated to people who make decisions, commissioners of health services, clinicians, and so on. And then that data needs to be acted on. And data doesn't do that on its own. Data needs people with skills to do those jobs. So let me run through a couple of the things that we have made. First up, open prescribing. So this is a service that we built to replace a lot of error-laden work where people were doing lots of manual labour in Excel to manage these enormous flat files of prescribing that have billions of rows in them in total, looking at what's being prescribed month by month in each general practice in the country. So in England, in case you don't know, there are 6,000 individual primary care providing general practices, each of which see their local population, and they're the sort of first point of contact in our healthcare service, the gatekeepers for referral onto secondary care, and a very successful system for managing cost and quality where it is adequately resourced and organised. So openprescribing.net, you can go and have a look yourself. When you get there, you get to see, this is a slide for where I'm doing this with real GPs in England. You type in your own practice and then you get to see lots of these kinds of graphs. So these graphs go left to right, 5 years of time. The dashed line is the national median, the dotted lines either side are the national deciles, and then the red line is the individual institution that you are looking at. So this is Beaumont Street Surgery, which is the closest GP practice to where my office is in the centre of Oxford. And this is the front page that you get when you arrive there. And if you click on any of the individual categories of measures, you get to see ranked with the thing where your GP practice is most outlierish, the thing where they are worst for the measures which have a valence, where high is bad and low is good. And so if you look at these, you can see the thing that they're highest on in the low priority treatments. So that's a list made by NHS England of things that they would prefer were not prescribed in primary care unless there's a very good reason. And you can see top of the list of the many measures that are in that category is liothyronine. So that's an unusual choice of treatment for people with underactive thyroids. And you can see the national median is actually at 0 because the average doctor doesn't prescribe this at all. The national centile to first decile, so 10th centile, is up at about 80 per 1,000 patients, £80 per 1,000 patients, and you can see that this practice is consistently hovering around there. Next up below there, you can see perindopril, which is an unusual ACE inhibitor to use, and again, these measures, the NHS England low priority measures, tend to be cost. Cost is not the most exciting thing. Quality and safety of care are the most exciting things, but I'm showing you the cost ones first. You can see here that they are big users of perindopril arginine, which is an unusual choice. So then next up, going further down, so now we're getting into, this is from our normal suite of measures, so not cost ones, but all of quality, safety and cost effectiveness. And here you can see they're very high users of less preferred NSAIDs and COX inhibitors. So there are lots of painkillers that people can use. Some have got data showing that they've got a particularly high rate of problems in stomach and kidneys and risk of blood clots. I'm sure most people here know about ulcers and non-steroidal anti-inflammatory drugs. That's why you're told when you buy ibuprofen over the counter that you've got to have it with food. And you can see that this practice is a really big user of the less preferred painkillers from that category. So that's the kind of stuff that you get to see on open prescribing. Here's a few more examples of measures, but I think you get the picture now. You can also run your own analyses, so you can say, hey, I'm interested in linagliptin as a proportion of all drugs used in diabetes. Give me the data by local area, so this will be integrated care board or sick ball, sub-integrated care board locations. The latest patch from the never-ending disorganisation of health services. And you can see here, this is a chart just showing the variation between areas, and then you can see it on a map. You can see that Rotherham is a really big user of linagliptin, and then you could go off and talk to people about why that is. Now, when you start doing this, you start getting a bit of a window into really the soul of the healthcare profession, really. I'll show you in a moment a few slides looking at adoption of new treatments and adoption of guidelines about existing treatments. And the question that often gets asked is, you know, who's the worst practice in the country, or who, you know, are there good and bad GP practices? The interesting answer is, in general, there are no good and bad GP practices. We looked for clusters in the data, principal components analysis, factor analysis. You can think of all the different ways one might try and do it. Overall, it turns out almost every GP is good at almost everything, and almost every doctor has a couple of things that they've overlooked. And that's actually rather a positive and inspiring message. Firstly, because it means that most people are good at their job. Secondly, it means that probably if you let them know about some of the things that they've overlooked, they'll either say, oh great, thanks for letting me know, or I already knew that, there's a good reason, or I already knew that and it's not our top priority to fix that amongst all the other things that we've got to do, but it's on our radar. So let me show you a few bits and pieces of the research that we've done on what drives variation in clinical activity across the health service. So first of all, you can do obviously lots of things like interrupted time series analysis to see what happens when new guidelines are brought in, when NICE says please offer tamoxifen as a preventive treatment to more women with breast cancer. You can see there's actually not very much of a step change in the number of people getting it. When the chief medical officer does a big push on antimicrobial prescribing, there is, I think, as you'd realistically expect, a true but very modest impact on antimicrobial prescribing. We've done studies looking at the impact of our own service on the data, in which we shared all the code and the methods before we even began doing our analysis, so that nobody could accuse us of cherry picking in the analysis of our own service. We've also done randomized trials. So the chief pharmacist in England said, hey, I'm going to go out and visit the 20 practices that are the highest users of treatments on the do not prescribe list, or the NHS England low priority medicines list. And we said, don't go and visit the worst 20. Make a list of the worst 40. We'll randomly assign you to go and visit 20 out of those 40, and then we can do a randomized trial of whether the chief pharmacist visiting or his office visiting has an impact on prescribing. I won't tell you the answer because methods are more interesting than results. We've also done lots of work looking at different ways of identifying variation in care, variation in activity, and in particular hypothesis blind ways of looking at the data. So this is from a series of analyses that we did where we said for every drug and every region, basically try and find us interesting patterns is the challenge that we set the computer, as it were. So this is what happens if you say every drug is a member of a class. Tell me the drugs where within that class there is the most disagreement between doctors about which is the best member of that class to use. We did it by using kurtosis and ranking by kurtosis on the proportions. You can find out more by reading the paper. And when you do studies, when you do analyses like that, you find things like this. So pyracyazine, a very unusual antipsychotic, only about 80 papers ever published on it in PubMed compared to 10,000 for risperidone or olanzapine. And you can see here that it's not used by anyone anywhere in the country, but it makes up about 1/5 of all prescribing in one region of England, in the Norfolk. Lots of different things. And then also we've built early warning tools to help you catch when there are problems before they get out of hand, where you've deviated from the norms of your peers. So if we look at this timeline, this is old data. Obviously the data in the platform live is very much up to date. This is just an old slide from when we were developing this bit of the service. So you can see that for this treatment choice across the whole country, everybody was pottering along at about this level as a proportion of all the prescribing. High is bad, low is good. It doesn't really matter what this measure is for, but I think it's switching from a branded oral contraceptive to a generic cheap oral contraceptive. And you can see that there was a point in time at which everybody was initiating change, and so they all began changing. The national average drops massively. This one practice was pottering along quite low, and then the whole practice of medicine around them changed across the country, but they didn't really get the memo until this point, and then they changed. Now, normally when you send people alerts or tell them that there's a problem with their prescribing, you do it by doing things like, oh, let's tell them if they're in the worst 10%, for example. But we wanted to be able to tell them earlier, so we wrote some code basically using a version of cumulative sum and set up an alert service around that, which means we get to send people alerts. As you can see, these red dots are when you'd get alerts pretty much the moment you start to deviate in comparison to your peers. Now that's important because that's a thing which we use to drive our real live service. And our real live service, because we do all of that filtering to tell you only about things that you care about, we filter out the noise. We don't send people reports saying, hey, here are 10,000 things that you should look at. We send them reports saying, hey, here is a very small number of prioritized things that we think are going to be important for you. But we can't do that by people looking at the reports because there's no person time, there's no budget for that. Open prescribing, by the way, has limped on a couple of £100,000 a year for most of its life. It's currently got about £500,000 a year in total from NHS England, but that's only for the last couple of years. Who knows how long this will last? So don't imagine just for 1 second that I'm some stuck-up sticky beak from the University of Oxford who's living in a golden palace made of money and data scientists and software developers. But by building this small service doggedly over the course of many years, by making sure that we meet real users' needs, by competing in a market, we've been able to get a phenomenal number of users. So there are about 5,000 subscribers to the alert service that I told you about just now, and the overall service gets about 20,000 users per month. So that's unique IP addresses visiting the site and the service. So what else can I tell you? Clever data science stuff to detect when people have changed their prescribing, when there is a discontinuity in their timeline. So we've used that to produce things like this BMJ paper, which is the largest paper ever done on diffusion of innovation in the health service, diffusion of change, when the system decides that you should start prescribing, in this case, for this graph, this is nitrofurantoin should be used instead of trimethoprim for treatment of uncomplicated urinary tract infection. You can see that at this dotted line, very few people change. There are a few more changes over time. So this is when Public Health England first said, dear doctors, please can you switch? And then finally over here, they said, please switch again. Not a lot happened. The time when they actually switched was when NHS England said, okay, we'll pay you if you switch. So you can do this kind of work where you can start looking at what are the drivers of change, what are the determinants of change, and then in turn use that to optimize adoption of new treatment guidelines. And we've also produced this, which is the improvement radar. So this isn't just about talking about problems. With NHS England, we're making something called the opioid improvement radar first off, where we look for practices or regions that have successfully implemented a warranted change. And then when you see that, that's an opportunity for other local services around the country to get in touch with them and say, hey, I can see that you successfully reduced your usage of high-dose opioids in 2022. Please can you let us know what you did and how you did it so that we can try and replicate it in our local area. So that's open prescribing. Let me tell you very quickly about Open Safely. So Open Safely is an enormous secure platform that we built for secure analysis of electronic health records data. It's got the whole population's records, 58 million people's data, and unusually for this kind of project, it hasn't set hairs running across the privacy community and privacy campaigners and professional groups. In fact, we've earned complete trust and support from professions and privacy campaigners. And we've done that not by doing lots of PR, we've done that by building new methods for privacy, transparency and efficiency, and by building new methods that protect patients' privacy and do it provably and transparently and in the open, we've been able to earn unprecedented scales of trust. We've also built it as a set of portable open tools that can be installed in any data center containing electronic health records data. And that was for a couple of reasons. Firstly, it was to avoid moving large amounts of data around and preserve the GP being the data controller for their own records. Secondly, it was to overcome the challenges of vendor lock-in. So to be resilient to the challenge of every time your data moves between data centers, it's stored in a slightly different way. And so you have to throw away all your own code because you've got to rewrite it from scratch. We wanted a portable way of analyzing data that wasn't particularly tethered to any particular computational implementation of the underlying records. So GP data in Britain, extraordinary resource. It's got breadth and depth, so one record for every citizen and lots of information about every citizen. You can use it for research of an academic kind. You can also use it for analysis of a practical kind to improve the quality, safety and effectiveness of care. And let's just quickly go through the data that we've got. So one row for every prescription, every diagnostic code, every referral, every appointment and its booking date, every blood test and its result, and so on. We've got that linked on to lots of other key health data sets, and we've got a bring your own data service where you can link in other research data sets and service data sets. It's produced a very large number of outputs so far, over 70 papers in glamorous places like British Medical Journal, Lancet, Annals, Nature, and so on. And if you go to opensafely.org, you can see a full picture of all the data and all the papers that have been produced by our users. Work on things like do monoclonal antibodies and antivirals actually work to prevent hospitalization and death from COVID? Who's actually getting them? Do vaccines wane over time? What about vaccine boosters for COVID? Who's getting vaccines? Are we producing sort of live real-time analysis? We've also done a lot of real-time service monitoring. So on the left, you can see doctors stopped doing cholesterol tests during the peak of the first wave of the pandemic, but continued doing urgent INR blood tests for blood clotting for people on warfarin. That's an amazing picture, by the way, of doctors adapting their care in the context of a pandemic. And it's not my group doing the work. It's 155 projects approved by NHS England, who are the data controller for the data, and those users are from 22 different organisations. So how does it work? As I said, it's open source tools for secure use of data. that can be built in any data center. And we set out to fix 4 major problems around working with this data. First up, privacy and transparency. This data is really powerful, but you can't let a huge number of people have access to the pseudonymized records of a whole population because of the privacy concerns. So if you know just a little bit about a person, it's very easy to find them in a data set, even if they've had their name and address taken off it, because if you know roughly where they are, roughly how old they are, if you know when they had kids or when they had a particular medical procedure, then it's very easy to identify them in the data. So removing names and addresses is not enough as a privacy risk mitigation to give people unfettered access to the data. So what did we do to work around that? Well, first up, we built our tools inside the data centers where the GP data already resides. In this case, the data centers of the electronic health record system suppliers, TPP and EMIS, who were both fantastic and worked pro bono during the pandemic, and TPP indeed are continuing to work pro bono. Open safely, in addition to the data not moving, it's not just a machine where you log in and have a remote desktop and then you have unfettered access to tinker directly with the records. We had to do better than that, build something more sophisticated than that to protect patients' records. So overall, what we had to do was invent new methods that let users analyze data in a hands-off way without interacting directly. We had to make open logs of everything that happens to the records. We had to share all of our users' code and share all our platform code. I'll show you very quickly what that looks like. When you go and see a doctor, every time a diagnosis is made, they add a row, an event to your record. Every time you get a treatment, they add a row to your record. You got an inhaler, this is what it was, this is the pack size, and so on. And analysts write code against that data, and their code is what prepares the data into an analysis-ready two-way table typically, and then they run regression code to do statistical tests, or they write and run graph code or code to make tables or whatever it is. We didn't want to give people unfettered access to the data, so instead the Open Safely machine gives you randomly generated fake patient data. You use that to write your code. When your code is ready to run, it's tested, it's shown that it's able to run against real patient data. That gets sent off and run in an automated hands-off system inside the secure vault that contains the real data, but no analyst ever gets to enter that and interact directly with the records. And then you get your graphs, your tables, your log files back to your machine. So first of all, when we made this, lots of people, campaigners, professional groups said, how do we know you really work this way? Because we've heard a lot of good PR spiel about these kinds of platforms in the past. So we said, okay, we'll put all the code for the whole platform in public on the internet so you can see it all at GitHub. Secondly, people said, well, we want to see what you're doing with the data, because it's one thing to protect privacy, but we also want to make sure that the purpose to which the data has been used is aligned with your permissions, because there's also a lot of concern, not entirely unreasonable, that sometimes data gets, people get given access to data and then use it for more than they had permission for. So we said, okay, fine, if you go to jobs.opensafely.org, we have provided an open public log where anybody who wants to can see everything that's happening to the data live and in real time. You can drill down to the actual code on the GitHub repository. And that's because the only way you can run code in OpenSafely is by, first of all, putting your code on GitHub, and then you instruct OpenSafely which GitHub repositories you want to run against the patient's records. So when we went to all that fuss, all that trouble, that was a mission. Did it work? Did we actually earn trust? Well, the answer is yes. Unprecedented trust from all of the people that have historically blocked access to this kind of data, and lots of positive coverage in the media, in Parliament, and so on. But we didn't just want to be secure, we also wanted to be productive. So efficiency and reproducibility, big challenges when you're working with these data sets. We took an approach where we said we're going to standardize everything wherever possible, automate wherever possible, take a service approach and make everything open. I'll just go very, very quickly through a couple of bits of that. So first up, converting raw electronic health records data into an analysis-ready data set is really hard. In general, everyone does it differently. Arbitrary SQL, Python, R, status, searching for event codes, that sort of thing. We wanted everybody, when they were doing the same jobs, to be doing it in roughly the same way. So we built tools to help people standardize their data management. Open code lists you might find useful even if you don't use Or you probably do use SNOMED CT and ICD, so it's a very good way of building code lists to identify conditions or treatments with quite cunning things to help you manage the challenges created by the poly hierarchy of SNOMED CT. I would imagine in a room like this, about 1 in 2 of you sort of roll your eyes and mutter and laugh and go, oh my God, the challenges of the poly hierarchy in SNOMED CT, the ever-changing poly hierarchy in SNOMED CT. So we built point and click tools to help you make code lists, and then also standard tools to prepare the data into an analysis ready shape, something called ERCL, Electronic Health Records Query Language. I highly encourage you to go and read about that if you're interested. It is a very widely adopted standard means of working with electronic health records, adopted by all of our users in the platform. And when you standardize and automate in this way, lots of good things happen. Oh my God, all my slides have gone wrong, but those have been used by all of our users and they find it very helpful. Next up, we wanted to make it as quick as possible for people to use the platform. So we've done things like, obviously, a simple application process. We've got a good co-pilot service. Every new user gets 5 person days of in-person support from an experienced user. We've got comprehensive technical documentation online. We put everything in the open, not as a political move, as I said at the beginning, but as a practical way to help people work efficiently with electronic health records. So there's about 80,000 words of comprehensive technical documentation openly available online for everyone at docs.opensafely.org. And because you start working on randomly generated dummy data, and because there's comprehensive documentation, you can actually learn about what it's like to use OpenSafely without even applying, without having permission to run code, because you can very quickly, using code spaces in your browser, set up an environment where you're writing OpenSafely code against randomly generated dummy data with no access to patient records, but you can experience what it is like to use OpenSafely in the same way as any other user. We've also made point and click tools for people who don't have coding skills, in particular people in NHS analyst roles that are more around communicating and understanding data, which is a perfectly legitimate subset of the group of analysts, to try and address that problem. And then lastly, we wanted to make it easy for people to share their code. In fact, we made it obligatory. You can only execute code via GitHub. And so because of that, everything run in OpenSafely goes in the public domain. So it's open for quality checks, efficient reuse, accountability. There's no opportunity for p-hacking because everybody can see you doing it if you do it. And this is a driver of true technical collaboration. It makes the platform extendable. It's public proof of delivery with public money, delivering a public good for all. And it means that every user contributes code and knowledge to this growing open stack. So it's a beautiful social movement in some respects, as well as a technical machine. So OpenSafely is now growing, more money from NHS England, still only 4 million a year, but that's enough to support the service at its current size, and we're expanding to non-COVID uses over the course of the next, hopefully, 6 months. Last up, I said I would talk about my review for Secretary of State for Health and Social Care in England, published in 2022. If anybody ever asks you to do a review for a minister, I strongly encourage you to say no. They're very time-consuming and anxiety-provoking. 200 interviews, 8 focus groups, 100 written submissions, 185 recommendations, 30 summary recommendations. The whole thing was 110,000 words. Please go and read it, because otherwise my life moments will have been wasted. I'm going to tell you in particular about the bits relevant to the NHS analyst profession, but we also talked about imposing modern open working methods and facilitating them for researchers and the NHS analyst workforce to improve productivity. I talked about the need for data curation as a foreground activity, data management as the kind of hidden burden in working with health services data, and also talked a lot about the power of trusted research environments, so building secure platforms like OpenSafely, but not exactly like OpenSafely, because you don't always need that extremely high level of privacy protections. Lots of data sets are less detailed and less coverage of the population, so you don't need to have the same high level of privacy protections as that, and so lots about the value of trusted research environments. Let me talk particularly about the NHS analyst community, bearing in mind that I only know about the situation in England, but I have spoken to some of your colleagues in PHONZ. If you really do call it PHONZ, that's surely inspired by the FONZ from Happy Days, right? That's a deliberate thing. And I've been told that the problems in New Zealand are the same, but I don't know that. So don't take that from me, take that from each other. Good data analysis, it's at the heart of everything that you do with NHS records. You can use it to monitor clinical activity, compare outcomes between different places, spot opportunities to improve quality, safety and cost effectiveness of care, and all the things that I've been talking about over the course of the last 40 minutes. But the data doesn't do that by itself. It needs to be managed, curated, processed, analysed, presented and interpreted by people with skills. Now, in the NHS, we've got lots of people with those skills, and we've got pockets of excellence, but the workforce is very dispersed. It doesn't really have a kind of formal home. There is an informal network of people. There is no there's barely a sort of set of formal job descriptions. There's no formal professional body for NHS analysts. There's no clear career pathway with technical job descriptions and associated skills and qualifications. There's very little formal structure around initial training or around continuing professional development. There's no commons of knowledge. There's none of the furniture of a profession. There are a few small-scale conferences run by enthusiasts, but no national conference until Health and Care Analytics started in the last 12 months. There's barely a single textbook other than generic data analysis guides from other adjacent fields. There's no library of methods, workbooks and code, and where analysts can get access to training and develop their skills, they often feel that that is kind of informal, voluntary, not properly rewarded, and that career progress only comes from taking on a general management role. So you can't become a higher paid, more senior, more expert analyst. You can just become a generic manager within your local health service. And because of all those challenges, there's massive variation in the approaches taken between settings. Lots of really excellent work, often driven by single groups, but without structures for sharing knowledge, that doesn't get easily spread. And there's a culture of very duplicative working behind closed doors. For national and local analytic teams, there's a lot of reliance on outdated and inefficient means of data management and analysis, a lot of point and click tools like Excel, which can be helpful for some things, but they can obstruct reproducibility, transferability, automation, error checking, and they're not really optimal as the default norm for a lot of the tasks that you need to do when you're running data infrastructure for a large national health service. Analysts also struggle to access data, and when they do get access, they struggle to use the kinds of platforms that give you access to huge data sets because they're expecting point and click if that's what they were using in a local service, and point and click tools often don't scale to very large data services, or at least not all aspects of the work. So at the very least, you need some people doing some hands-on coding to make the data accessible to people who've only got point and click tools. So a kind of pervasive sense of a profession with huge potential waiting to be unleashed. And I made a series of recommendations around how to do that. So first up, create an NHS analyst service modelled on the Government Economic Service and Government Statistical Service. So those are things that already exist in other bits of government in the UK. They've got a head of profession, clear job descriptions tied to technical skills, progression opportunities where you can become a senior analyst rather than just a manager, and realistic salaries where expensive specific skills are needed. I talked next about the requirement for embracing modern open working methods for NHS data analysis, committing to reproducible analytical pipelines, which is a brand created by Office of National Statistics for modern approaches where you share your code, document it, and so on, and make that the focus of core NHS analyst training. I talked about creating an open college for NHS analysts, which could devise and coordinate the delivery of a curriculum for initial training and continuing professional development tied onto job descriptions. Because if you want to get people to do your training, you've got to make it clear to them that there's personal benefit for them. And recommended that all training content should be shared openly online to everybody so that the information is easily accessible. In the modern age, you don't want to just empower your own people that you're directly targeting and paid to target. You want to empower a whole population. It might be the place that one random person chooses to start learning about data analysis and then build a career or build a business. And that training needs to cover a range of skills and roles, not just deep data science, but also data communication and so on. And then Next up, recognise the value of knowledge management. So everything that I was saying about data curation, but also better ways of people sharing their skills and knowledge and working patterns and recipes and templates for common tasks across the different bits of the health service, to help spread knowledge and examples of best practice, but also to help share whole blocks of reusable work that people could take off rather than constantly reinventing the wheel. And then make sure that wherever you buy help, whether it's from academia or from the commercial sector, what you buy is a buyout of the intellectual property and the code. So it all goes in the public domain so that there are no restrictions on sharing, because if you're trying to build community, if you're trying to build knowledge, allowing commercial restrictions on the sharing of that knowledge just doesn't make sense. There are obviously many situations where aggressively protecting intellectual property make an enormous amount of sense for a productive economy, and this is not one of them. And then very lastly, and this is the kind of room where this sort of thing goes down well, it's not the only thing to do, but it is an important thing to do. Train senior non-analysts and leaders in the system on how to be good customers of data teams, how to ask good questions. So, look, it's a busy world. I'll stop talking. Very kind of you to ask me to speak. I hope that was all useful and interesting and relevant to your work on the other side of the universe. I love and miss New Zealand very much. I hope you're all having a very nice time there, and thank you very much for listening.
Patrick and everyone. So that was Ben Goldacre. He was a little bit disappointed when I said we couldn't afford to fly him over. But he was good enough to give us one of his fireside chats that you can see that he's hauled that out a few times, or more than a few times. There's 116 slides in that deck. And he really has been working for analysts in the UK. Over 10,000 analysts. And by my reading, we have the same problems that you guys have in New Zealand. But his tools and this concept of open data, I think, could really push us forward in terms of shared resource and learning. I'd be keen for people to put in the chat your thoughts and feedback. I see there's one hand up, Patrick. Somebody wants to make a comment?
Yes, Sam, if you've got something to say, feel free to chip in. I've let you unmute yourself if... Nothing to add.
Patrick, Chris, can I just make a short comment there? I think it's
Sure.
it's reassuring and scary that the UK is having the same issues that we have had, and you know, traditionally we've always followed the UK, but maybe we're a little bit ahead. I think that every comment that Ben made, particularly at the end, was absolutely pertinent to the very ideals that FONZ is about, because one of the things that we've tried to address is some of those issues that he's actually raised. So I think there's lessons there. I think the question that I'd really have is, where does the driving force come from? These issues that he's mentioned, we've talked about in FONZ, are not new. And we always come up with the problem, but I don't think there's any central guidance about what it is actually to be solved. So one of the beefs that I've always had is that we don't train managers in interpretation and communication. I think that's part of the conundrum that we do here.
Yeah, that's been identified in the NHS in particular, which is slightly different than public health analysts would, like myself, would have experienced. But it really is a parallel. And I think it's the urgency of getting the NHS back on track. The new government has declared it as a broken service. That's their policy going forward. The NHS is broken and we got to fix it. And Ben has really provided some solutions in terms of how we can extract more value from that huge data resource of billions of records in a way that it's completely trusted by some really important characters. And they've made it all entirely open. So I don't think there's anything preventing New Zealand from adopting that code and those processes and running it through their system. Len, did you want to say something?
Just a little comment. Having spent time in both New Zealand and Britain producing statistics, I think it's important to recognise the massive base of user services and support in the UK compared to New Zealand. The Essex Data Archive started coordinating British data from all sources in the 60s. The UK Data Archive was extended in about 20 years ago. And I think the difference between New Zealand and Britain is the massive effort that users themselves make to push the system along. In my view, both official statisticians have very little understanding of how people really use their statistics. And I think that's something that we underestimate the significance of. But secondly, somehow or other, I just put that on. Secondly, in my view, the users of statistics in New Zealand are much more docile than the users of statistics and data in Britain. For example, in the UK, the Royal Statistical Society set up its own user group when they wanted to push the statisticians along. I think users, the sort of changes that have been talking about really have to be driven by the people who want to use them at the other end. Just a wee thought, don't rely on the system itself from inside it, because those of us that are inside it really have a very limited understanding of what people do with the data.
And that really is the added value from somebody like a Ben Goldacre. He's not in the system. He very much considers himself to be a rebel in that regard, as much as an Oxford professor can be a rebel. Okay. Yeah. Thank you very much for that contribution, then. That was excellent. I think we have to move on at this point, almost, unless there's anybody who's got a final comment to make. Great. Okay. So now we've got a series of talks, which are absolutely fascinating. I think anybody who's come across academic fraud in their careers, or even the whiff of it, it's a very odd feeling to find a fellow scientist or analyst that would actually manipulate data in a fraudulent way. I mean, it just, I don't know, it just seems, despite all the pressures in academics, it just seems such an unusual thing for somebody to do. I ran into this in 1990. I was lucky enough to be a graduate student at Macquarie University in Sydney. And I got to know a little bit of a fellow named Professor John Tallant. And he was a geologist and a paleontologist. Unfortunately, he died earlier this year. And he discovered some frauds in the fossil records of India. I think it's called the Himalayan fossil fraud. You can Google it. And it's extraordinary how an Indian academic managed to fabricate enough fossil finds in the Himalayas to completely distort our understanding of the paleontology of that particular region. And it took John many years to uncover what had happened. And he wasn't paid many favors for it. I think he found it a very stressful time towards the end of his career. So we've got a number of people. We've got the first two speakers, or the next two speakers, sorry, are Leonid Schneider and David Bilmer, and they're both related or work for Better Science, a website, for betterscience.com. And they've both got some stories to tell us in a recording today. So what we'll do is we'll play those. I think we'll play the first one and then we go to break. Is that right, Patrick?
Yes.
Yes.
Yeah.
Yes,
yeah.
That's right.
Okay, so that's what we'll do. And then we've got a 5-minute break after that. Again, feel free to put your comments in the chat. And at some point during the break, Patrick's going to share a Mentimeter slide, which allows us to create a word cloud with all our thoughts and feelings on this. All right, Patrick, take it away.
Good morning. I'm Leonid Schneider. I'm an independent science journalist, an activist for research integrity, and the person behind the notorious evil terrorist website forbetterscience.com. And I First, I would like to thank the organizers of the PHONZ Conference, Barry Borman, and others for inviting me here to give this talk, which unfortunately is recorded for the reasons of major time difference between New Zealand and Germany, and the fact that I will be on vacation when are you listening to this talk. So, my presentation is about revolution against science fraud. And I will first talk about how the scientific method became circumvented, that fraud is part of science, and I will talk about paper mills, the broken academic system, and make proposals how science can be fixed. So, here my personal opinion where research fraud came from. So you know that before we had science, we had natural philosophy. And natural philosophy went without experiments, mostly. So a man had an idea. It was always a man who were allowed to have an idea in those times. And this man argued for his idea. Either the ideas were accepted or not, but when they were accepted, they brought respect, status, and money for the idea holders. At some point, when science arrived, it brought the concept of experimental proof. So if you postulated that flying pigs must exist, you had to prove it experimentally. You had to catch a flying pig, for example. Otherwise, you wouldn't be believed. But what will you do if the experiments fail to support your ideas? For example, obviously, you can't find a flying pig ever. And this is where science fraud comes in. So you take a pig, you sew some wings on it, and then you present your evidence. So I would like to argue that science fraud is as old as science itself. At some point, science became a profession. As you know, earlier scientists like Darwin and others, they did science because they inherited a lot of money or were otherwise very wealthy. So they didn't need to work as scientists, to earn money as scientists. Eventually it became a profession, but what academia retained, it's all an ancient medieval hierarchy, because obviously the universities were church institutions, and the university hierarchies are taken over from the church. So, how does a hierarchy work in the praxis today? Well, there's pressure from above that if your professor has an idea, your job is to support this idea with experiments. And if you fail to support them, the professor is unhappy. But you fail to support the idea. And there's pressure from everywhere else, from your family, from the society, that you need a job to live, to buy food and to pay for your apartment, to pay your rent. And then, of course, there's a peer pressure that swimming against the current is a bad idea. Nobody likes to be an outsider. So if everybody in the lab you work in works sloppily, let's put it this way, it will be very difficult to stand up and protest against it and be the only one who works in a different way. And the other thing is, when the entire system is broken and it promotes, incentivizes research fraud, it makes it even more difficult to swim against the current. So this is a very philosophical approach, or psychological maybe, which many people ask. If the scientists commit fraud out of intent or out of incompetence. And it's very important in research misconduct investigation, because they always say, well, unless we find an intent to commit fraud, the person is innocent, which is, of course, complete nonsense. So cases of intentional fabrication are indeed very rare. So it's very rare that you have a scientist who never does any experiments and just invents, fabricates everything out of thin air. If we take the paper mills aside, of course. But what is very common in science, in experimental science, is the intentional fabrication. Because when your results don't fit, you make them fit. And my personal belief from after several years of doing what I do is that research fraudsters actually fully convinced that they're honest and it's the reality which is lying. They really believe that even if they manipulate data, it's actually not research fraud because they merely adjust their results, the failed experimental results, to fit the reality as they imagined it to be true. It's very difficult to understand, but I think this is what goes on in their heads. And this is what I would like to say, that intent to cheat is actually a red herring. It makes no sense. It doesn't need to be proven. It doesn't matter if the scientists fake data because they're intended to cheat or if they're just that stupid. In either case, they have no place in academia. And then we have a collusion of interest, which when we are reaching the publication industry. So scientists, since science is a hierarchy, then of course people want to rise in a hierarchy, which means promotions. And for promotions, you need to apply for and present something to qualify for promotion. And in academia, they just, like everywhere else, they like to measure people by numbers. So, like in a school, you get your grades. In academia, you're counted by the number of your papers, journal impact factor where those papers were published, and how often your papers were cited, or meaning your own personal Hirsch index. And on the other side, we have the publishing industry, which people believe is supposed to have any ethics about their content, but it is very strange. You don't expect the tobacco industry to have ethics about the product they sell, or alcohol industry. So, and publishing industry is the same. They're interested in making money, in selling papers. They sell papers in two ways. They sell you subscription bundles. So to library, they sell to university libraries have to buy subscription bundles, and they sell papers to scientists directly via the gold open access. And the scientists pay to publish. And this creates a perfect shitstorm. And then, of course, we have the reputation game, which is part of those metrics which the academia needs to measure scientists. So, peer review, which is supposed to define quality science from trash science. And it was only invented in the mid-20s. It's not an ancient institution, as some believe. So journals compete for contact, and they rely on peer review for verification. The assumption is that the more higher ranking a journal is, the better peer review in it, which is, of course, nonsense. But this is the assumption that the impact factor measures the quality of the peer review. In reality, it just was invented to measure journals' popularity, not quality. But nevertheless, because we need numbers to measure everything, scientists, media, and the society fell for it. And that's why we believe that Nature, Science, or Cell are the best journals on the planet. So, I would like to argue that science fraud is actually the rule and not an exception in science, unfortunately. Just like war is the rule and not peace, I'm afraid. Same goes for science fraud. The problem is that scientific method is too slow to compete with fraud, or bullshit. So it's very easy to produce a fraudulent or dishonest paper, and it's extremely difficult to debunk it, as many of you probably know. And then there's a concept in a society, but also in academic, of course, in academic community and among the publishers, that scientists cannot commit fraud because they are different from mortal humans. They are on a different ethic levels. They are superhumans. So they will never steal or cheat or do anything or commit any form of misconduct because they are scientists. And this is why assumption that a paper is fraudulent is always rejected, and they try to find a different explanation. For example, that there is no intent, that it was honest mistake, or any stupid explanation goes. So, and because of this, scientists don't have to prove hard their results. They just have to follow a certain template and in experimental proof, and anything will get accepted, no matter how outrageous the claim is. So yeah, and this template is very important because the amount of bullshit science which was generated over the decades created a template of what a paper must look like. What is suspicious is not outrageous or stupid or fraudulent science. What is suspicious when science starts to deviate from the template. And my theory is that it's actually honest and real science which deviates from templates because it looks different. And the paper mills, are producing products which look exactly like the template. And this is why this gets accepted by so many journals and so many editors who honestly believe that this must be science because it fits the template 100%. So this is where we reach the paper mills. Paper mills are an Asian phenomenon. They come from different countries. All of them are in Asia. So the idea is the scientists in those countries don't have much money to do experiments, but they still want to compete with their peers in the West. And the paper mills offer you entire paper just for money. So you don't have to do anything, just pay. It is a logical consequence of scholarly publishing system. If you created a template of what a paper look like, if you measure scientists by the numbers of their publication and their citations and the impact factor of their journals, right? This is what you will get. You will get paper mills. They are better than actual science. They're more convincing, they're elegant, they can be produced in huge numbers. So a paper mill scientist easily looks like a perfect match for any academic position, also in the West. Our universities are full of PhD students, postdoc, even professors who made their careers on paper mills. And what you can buy entire papers, you can just buy an authorship, you can buy citations to your own papers. So, since we're in New Zealand, you must know about Smut Clyde, who is portrayed here. And he will be giving you a talk also, as I understand, and I won't tell you his name, so he probably will tell it himself. So he is the leading paper mill sleuth, and I'm very honored to work with him, and I'm very happy that he continues writing articles for Better Science. And just to be fair, there are also other paper mill sleuths like Alexander Magazinov and Elizabeth Big contributed quite some, and there are also other anonymous people. So paper mills, as I said, they are from Asia. China and Iran have enormous paper mill industries, enormous. But there is also Egypt, Pakistan, this country which I don't want to mention, and there are other Asian countries. So who are the paper mill customers? As Matt Clyde found out in biomedicine, and in case of Chinese paper mills, those are doctors without labs, because in China you need to publish in order to get promoted, even if you're a doctor in a village hospital. But also active scientists are all over the world buy from paper mills, not just Asian scientists, as it happens. Although my theory that the let's say white European or white American scientists don't have to pay, it's enough that they're white, European or American, and they get the authorships for free, but they still take them. Why this happens? Why do they get those authorship gratis? Because the scholarly publishing is racist. Papers from people with Asian names are treated differently when there is one, let's say, white name on them. And sometimes paper mill even invent authors for the same reason. Some white European or American authors to get the paper published. And we had also cases where third world authors were invented from very poor countries like Burundi or Kyrgyzstan. And this was done to get an APC waiver because some publishers have a special offer to authors from those poor countries that they don't have to pay for publications. So it's funny that the paper mills scam the publishers out of money. I continue on the topic of paper mills. Special issues are the main entry point for paper mills. And this happens that paper mills have their own scientists they collaborate with. Those scientists get approached or invite themselves by the scholarly publishers as special issue editors. And then they organize, they work with the paper mill to get masses of papers in which they all wave through, obviously. Because it's the special issue editors who handle the peer review, right? The bestsellers are reviews because they're very easy to write. And publishers love review because reviews contain hundreds of references often, and which raises the impact factor of the journal, of course, if there are self-citations. Hindavi's widely retracted, actually it's not 8,500, I'm sorry for the mistake, it's probably I think 11,000 publications by now of paper mill origin. After that, Wiley closed Hindavi down and dissolved it completely. So Hindavi doesn't exist, you imagined it. This publisher never existed. That's what Wiley wants you to think. Other publishers retract much less. Elsevier, for example, it's a glacial speed with which they retract papers. MDPI is the worst because MDPI understands that the paper mills are their business. In fact, the entire scholarly publishing needs paper mills, all of them, because without paper mills, they expanded so much. Without paper mills, they won't survive. Well, now we return to academia and its broken system, and we have this unnatural selection. Because a bad scientist mentors further bad scientists, who in turn mentor further bad scientists. And this is how the jobs are awarded in the end. Everybody else just wastes time, money, and their careers with their irreproducible or even fraudulent science those people published. The work more or less destroy people just quit science completely, or just some of them engaged in bad research practices themselves. Then, of course, because science is very hierarchical, academia is very hierarchical, we have a massive problem with bullying, harassment, and power imbalance. And it always goes hand in hand with research misconduct, always. When you have a bullying professor, you must expect fake science, because when people are afraid to lose their jobs or their residence, which is often coupled to the job, so the visas, they will engage in research misconduct to please the professors and make sure they are not fired. And then, of course, who are the favorites of the dishonest professor? Those are the dishonest PhD students. And those are the ones who will become professors themselves, and so on. So in the end, crime does pay. When people get caught, it's always honest mistakes, figures, which are actually the only data in biomedical papers, become pointless and easily replaceable illustrations. Even if forgery is proven, it never affects the conclusions for reasons unknown. Then there's an argument that, well, you caught me with 20 fake papers, but I published 200. So it's just some papers of many. Another argument, which is popular in academia, that it's wrong to call out research fraud because it endangers society's trust in science. So basically, you're worse than anti-vaxxers and flat earthers. You are an anti-science zealot. Then, of course, there are networks, because every research cheater in a high position, they already have the established networks, and they can retaliate using those networks. If things go very bad, there will be scapegoats and sacrificial lambs. There will be a student or a postdoc or somebody else. Somebody will get to blame. Somebody expendable. And in a very, 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 very worst case, when a major research fraudster is found guilty of research misconduct, they will be given a second chances. They will be forgiven at some point. Who is never forgiven are the whistleblowers. So my argument is denying disease is not helpful. People did it with COVID-19, and it was not helpful. And the same thing is with research fraud. And who is in charge of investigating research misconduct? Unfortunately, it's very wrong people. Most countries lack national research integrity authorities. I don't know about New Zealand, I must say, but I know that Australia doesn't have one, and Australian universities are corrupt beyond belief. It's ridiculous how much fraud goes on there, and approved from by the very top. And this is because universities are very biased and conflicted. Of course, they don't want to admit that they embezzle the money for fake science. They certainly don't want to return the money, and they don't want to lose further funding to their dishonest scientists. So they're not interested in finding fraud. Publishers, journals, whom people expect to investigate it, are completely wrong instance. Why should they waste their money and their resources to scare away authors, to scare away customers? It makes no sense at all. Journals just do the absolute minimum to save their reputation, and when they believe they retracted enough to save their reputation, they stop. Or sometimes, in most cases, they don't retract at all to save their reputation. When media reports, things change. That's why journalism is very important. Unfortunately, hardly any journalist will report about a case before there is official research misconduct verdict by a university or a different authority. So the argument that I believe it is fraud which discredits science, not reporting fraud. So I have cases which science fraud was served to create fake news and discredit science. So we have the Pierre versus case of fake heart stem cells, which damaged cardiology and stem cell research for many decades. And there is fake IQ and race science research by Richard Lynn, which still gets cited by fellow racists and fascists. Then there is Didier Rowe's fake COVID-19 cures and his unethical clinical trials with chloroquine and ivermectin and so on. And then we have, of course, constant fraud in nutrition and alcohol research telling you that chocolate, wine, and coffee are superfoods which will cure all diseases, make you live forever. Okay. Just put those keywords in PubMed and you will see the amount of papers. So fraudsters can create their own research fields, like Anversa did or Richard Flynn did. And it's very difficult to debunk it. Fraud can also undermine trust in science facts. When we have fraud in pesticide research, like with the serraline glyphosate case, people stop trusting real research into pesticides, which warns them about the dangers of those pesticides. We had a lot of fraud in tobacco research. Luckily, it's very difficult to go back and say, well, maybe cigarettes are healthy after all. We have lots of fraud in vaccine research. You know how dangerous that is. There's fraud in gender research. A very hot topic because a lot of people deny that this research is relevant at all. And there's, of course, fraud in climate research, which is an even hotter topic. I would like to argue with an example. We don't, because, of course, a lot of cancer research is fake. But there's still nobody who steps up and say, well, look at all this fraud in cancer research. Maybe cancer is a myth. There is no such thing as cancer. This doesn't happen. So why does it happen with climate research and vaccine research? I don't understand. So, in the end, anything goes. Just tell them a story. Data is illustration. The conclusions are not affected. And we have to prevent this. We have to stop this attitude. So, fixing science needs experts. And who are the right people to put in charge to fight against bad science? Well, journal editors and publisher executives, obviously, right? And academic leaders, top professors, university presidents, and so on. And of course, we need experts with an established record of peer-reviewed published papers on the topic of research integrity, right? With high H index, preferably. None of them is actually the qualified expert. It's you. We need a rethink. First of all, we need to stop publishing as we do. We need to bring down the numerical evaluation and publishing system, which is the root of all problems. You don't need some anonymous peer reviews to read a paper for you before you decide if the paper is true or not. You can do it yourself. If it's a paper in your field, obviously. Well, you should understand we are not writing paper for those 2 or 3 peer reviews. You're writing them for your scientific community. And we should never outsource research ethics to commercial publishers. We did not outsource the research on the dangers of cigarettes to the tobacco industry. And we should not do the same with research ethics and commercial publishers. So one way to bring the system down are the preprints. Preprints, you probably already know them. They can be published online. They're without any cost to you before, during the submission. They protect your intellectual property from scoops. So no peer reviewer can steal your data now and publish it as their own because you have priority by publishing a preprint. You can publish all results, even negative, contradictory results. Anything can be published. There is no editor to stop you. Of course, they are not peer reviewed, and luckily, now many journals expect preprints. During the pandemic, it became actually a norm that you had to publish a preprint first. So there's an argument, of course, a lot of bad science was published during the pandemic as a preprint. But important is this was very swiftly debunked when it was eventually, even if it made into peer-reviewed journals, it looked very, very different and didn't get the attention anymore. An important thing that the most dangerous COVID-19 studies appeared in peer-reviewed journals. Papers by Didier Raoul or this this mega fraudster Sapan Desai, who published in New England Journal of Medicine and in Lancet. Or sometimes they just publish this data-free press releases and still the journalists run with it. So my major advice is for you to use the website called PubPeer. It is basically an online forum where you can comment on every paper which has a DOI. PubPeer was founded as an online journal club, but it became a whistleblowing platform for data manipulation. And this is why I advise you to, before embarking on a collaboration with somebody or trusting somebody's papers, you should search for their name on PubPeer, and then of course click on the links and read them. Don't assume just because somebody has papers on PubPeer there must be a fraud. I have papers on PubPeer where people posted random things, and now some people use it as evidence against me. Again, you have the power. So my advice is pre-print your research. Never compromise your own research integrity. Do not work with bad scientists, bullies, or harassers. Don't believe that you can change them, because they will change you or break you. Engage in post-publication peer review, for example, by using PubPeer. If you find something wrong in a paper, you should post it on PubPeer. Expose reproducible and bad science, you can do it either on PubPeer, or if it's happened in your research lab or in your institute or university, you can do it using the proper channels. So you should always report research misconduct, and my advice is don't do it alone, find somebody to do it together or to support you. You should notify the research institutions, the funders, and if everything fails, you should notify the journalist. Important is that they are more afraid of you than you of them. So, and I would like to close with this. Here is my contact data. You're welcome to write to me. And if you want to use my cartoons, they're all CC BY, non-commercial, non-derivative. Thank you very much. Goodbye.
Okay. Welcome back, everyone who's made it back. Everybody's very quiet at this point. Our next speaker also provided a recording, but unusually he's online from Liverpool, live, David Bilmer, with the most interesting handle you've ever heard of, Smut Clyde. I'm sure we'll figure this out, and perhaps some of you already know. David is a semi-retired perceptual, really interested in color vision, facial expressions, and attachment theory. And hopefully he'll have a little bit more of a bright upside. Take it away, Patrick.
Right.
Oh, hi. If you're listening to this, I'm in Liverpool at the moment, quite possibly in a pub. I hope to be available for questions afterwards if the internet and time permit. Thanks to Barry for inviting me, and thanks everyone for tuning in. The point of this talk is to convince everyone that fake science or fake papers are a serious problem for science. The title says parody science. I could just as well have said cargo cult science, because it's about manuscripts that look like real papers but aren't. Science has somehow entered this weird situation where people who want to be published researchers can buy the equivalent of a plane made out of bamboo. It doesn't fly, but they still get credit for it on their CVs. I'll give some examples, and at the end, where I'm supposed to offer remedies, I'll just wave my hands helplessly. So here's something that happened at the beginning of the year in the journal Bioengineered. This is put out by the publisher Taylor and Francis. They retracted 9 papers in January this year because the editors no longer had confidence in the contents. Then on February the 20th, they retracted another 45 papers. So the 90% of the journal's table of contents for the year for 2004 consisted of retractions at that point. You'll notice the emphasis in the titles on non-coding RNA. There's long non-coding RNAs, there's microRNAs, or even these circular RNAs. We'll come back to those. At the same time, there was a kind of a massacre in the board of editors. The editor-in-chief was dropped, ousted. So were all 4 deputy editors and most of the associate editors. I can only suppose that the publisher was concerned about the direction that the journal was taking and about all those bad papers that should never have been published in the first place. So they staged an intervention. This is how I imagine the scene in the editorial offices when the publisher's deputation arrived to explain the changes in policy. So not long ago, a journal retracting 50-odd papers at once would have been newsworthy. Here, these images are these are stories from the blog Retraction Watch. This is because that's a lot of papers that were based on made-up evidence that were only published because the peer review process had been corrupted. But the numbers have been growing and will be becoming harder to shock every year. A lot of these scandals happen in special issues where guest editors offer to find papers in a special area of interest. In this last case, the number of Hindawi retractions has now exceeded 10,000, and they're still continuing. So the background story there is that Brian Napak, CEO of the publisher John Wiley, decided that the smaller publisher Hindawi had a management structure that was a good fit. It was basically the future of publishing. Hindawi had a flat structure and low overheads, and they outsourced all the expertise, and they specialized in the open access author pays model for publishing. So in January 2021, Wiley bought Hindawi for $300 million. This was too much money, according to business analysts, and only made sense if Wiley scaled up the cash flow, publishing more special issues in the Hindawi journals, and basically accepting everything, new policy of reject nothing, which is what happened. And then the industrial scale paper fakers were happy to provide the material. I note that Hindawi had a well-regarded integrity officer, Matt Hodgkinson, but he left at this point. Now, fans of science fiction will recognise the parallels with Dune. At any rate, it all ended badly. And Wiley had to close 19 journals because they were just so compromised. They dropped the name Hindawi as a separate department. Now Wiley has a new CEO, and the sandworms ate everyone else. So is there a problem? Well, there's a guy called Mohammed Taheri, who is mentioned here, who wrote a series of literature review papers about those non-coding RNAs in various medical contexts. Things like cancer cells and radiotherapy, long non-coding RNAs, and the pathogenesis of melanoma. Then he persuaded the Dean of Sciences at Sydney University to be co-author of 5 of these. The trouble is that this research area is thoroughly contaminated by paper mill effluent. It could be, 10% of the papers on non-coding RNAs would be fake. Taheri didn't worry about what was real and what was made up, for the purposes of drawing his conclusions in these reviews. He just treated all papers as equally credible, which is garbage in, garbage out. So now the journal editors are deciding whether to retract these literature reviews or let Tahiri to try to salvage something. But the foundations are completely rotten. It's full of termites. And meanwhile, Dean Dinger is having a bit of a hard time about it. I should mention that Tahiri is possibly running a paper mill himself with all these reviews. That's another matter. So basically, non-coding RNAs are the dark matter of cell biology. When they were discovered, it became an exciting research area. Any paper about them was sure of an uncritical reception. So we got fake papers at an industrial scale. One of these paper mills generated a lot of these flow cytometry scatter plots up at the top left. Every dot in each of these panels is a single cell, and the coordinates are the measurements of cell proteins on the cells. So if unrelated papers have figures that show the same dots, clearly there has been a problem. I have to say that they remind me of Spiny Norman. Meanwhile, on the lower left, the lower right, there's one of these cell cycle histograms that show the number of cells counted at the different stages of the cell cycle. If cells get blocked at some stage, this is good for stopping cancer. But the histograms naturally should not overhang. They shouldn't look like saw teeth. They shouldn't stick out sideways. So these are all just made up. And they look like Lionel Feininger's paintings of churches. And the millers also illustrated their creation with Western blots to show protein expression under different conditions. First of all, showing them as these ransom note styles, all cut and paste but the same little blobs recurring. These got replaced with a kind of string of sausages format. Then after another year, they became these ink blot patterns of ink soaking into a blotter paper. And then what look like rows of bow ties. Maybe they're Christmas crackers. Since then, the paper millers moved on to new algorithms for faking images. It's harder to convince the editors of journals that there was a problem. They even uploaded their fabrications to preprint servers before finding homes for them in journals. Here are some examples where the Western blots started out in the preprint version using the string of sausage format. Then the published version, they were replaced by ink blots up at the top and rows of bow ties down at the bottom. So there's the evidence that the different styles of fake Western blots are all from the same paper mill. The thing is that real Western blots do not look like any of these, but this is a whole literature where a whole cohort of journal reviewers have seen so many fakes that they have unrealistic ideas of what Western blots should look like. They probably turned down authentic ones. Basically, this is Western blot pornography. Here's another example of Western blot porn from a different paper mill. It had ways of generating fake blots by superimposing squiggles on recycled backgrounds. Here we've increased the contrast on some of these images so you can see that the grey background texture is actually the same on every band. So again, Western blots never look like this, but the journal editors and reviewers just don't care. They remind me a bit of dancing sardines, but I was overruled and it's become known as the tadpole paper mill. And at the bottom left, someone spent a lot of time creating the fake flow cytometry scatter plots, sitting there going dot, 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 making lots of dots. These are very weird diagrams. And here's another example of the tadpoles and these weird dot pictures. moving along. So this is how the business model works. Suppose that you are an academic somewhere here, and you need a paper in your CV to get tenure or to get a promotion. So you contact a paper mill, or rather you deal with a broker, a concierge. It's the broker who deals with the paper mill, and the broker also handles negotiations with the journal that's targeted. Some money might flow off to some of your money might go to the mill. Some of your money ends up going to the journal for their publishing charge. Some might go to pay off peer reviewers or corrupt editors. The fake images might be the work of an art studio, a separate contractor, separate from the paper mill. Anyway, ultimately money flows from a funding source, or it might be your savings, ultimately ending up at the fraudsters and the publishers, along the way producing falsified results as a side effect. For some reason, all this reminds me of the Napoleon's Grand Army on the way to Moscow and back. And to be fair, not all the paper mills follow that model. A couple seem to be in-house operations that serve the faculty of various universities in China, or rather the faculties of all the hospitals and medical schools that are attached to the university. Yet these in-house paper mills operate with the blessing of the administration, so that staff and students can get their fake papers without taking risks with untrustworthy cowboys. In this spreadsheet, there's about 150 papers. No time for details, but I'll just say that the studio produced an awful lot of these xenographed tumours grown using live mice as incubators to show that various treatments slow cancer growth. Here's another set of these fake images recurring across many papers. And moving along, and a different studio from another university, all colour-coded to show the different departments within the university. There are some recurring names there because even if it's a student who commissioned one of these fake papers, the head of department gets credit for it as well. Now for something completely different, crystallography. This is a niche area of metal organic frameworks, which are kind of exotic metacrystals assembled from organic molecules and pinned together by metal ions at the corners. I found over 800 papers reporting new structures of this form and finding medical applications for them, which is like treating cancer or hepatitis. So basically it's a floor wax and a dessert topping. This because the people who bought authorship on these papers were medical clinicians, so they needed medical applications. But the real authors were crystallographers who don't know very much about biology. And of course the editors and peer reviewers of the journals were crystallographers as well. So they didn't notice the biological absurdities. In this example, they claimed they were infecting laboratory mice with hepatitis B, which in fact is completely impossible. But the paper millers meanwhile deposited their made-up crystal measurements within the Cambridge Crystallography Data Centre to make it all look more plausible. They recycled images across their products because, after all, who is going to notice? At the top left, there's a couple of Fourier transform infrared spectroscopy plots for different papers and different metal organic frameworks. And the X-ray microscope images got recycled over paper after paper. At the bottom left, there are cells multiplying in dishes full of nutrients, where details of one image turn up in a different paper as a different combination. And they had flow cytometry, and they had thermal gravimetric analysis, all recycled. This is Smut's corollary of Rule 34. If there's a kind of image data that can be presented as evidence, someone is making fake versions of that kind of data. This all presented the Cambridge Data Centre with a bit of a problem, which is how to remove fake papers from their database. Fortunately, they managed. So the convenience of arranged science and a bit of a continuum of scale, showing from the high impact end at the top to the small scale end at the bottom. Mainly I'm looking at the small scale. This is where the paper mills are. The titles generally have a template created by kind of Mad Libs. But moving along here, I'm just saying that people write manuscripts. This is another phenomenon. I'm going to have to skim over this quickly. There are papers being advertised for people who want to pay to be co-authors. There's a lot of this. Nick Wise is a student at Cambridge who needs excuses to avoid his PhD work, and as part of that, he infiltrated many of these marketplaces. So there's different kinds of paper mill, all picked up in different ways, depending on the particular application of science. And it's the blind sages and the elephant parable. We're all seeing different aspects of this whole paper mill phenomenon. It's all being driven by the same underlying economic force. People need papers. I'll just speak very. I'll have to skim over the slide just to say that the paper mill activity does not contaminate all research areas to the same extent. Clever people made these landscapes of science by running all of the PubMed library through similarity mapping software and plotting papers as single points, and 2 points are neighbours if they have similar text. At the top, Goldacre defines similarity between pairs of abstracts. At the bottom, Adam Day defined similarity between titles. Either way, each area of science becomes an island within this sort of archipelago. And when you colour the points that came from a paper mill, they turn out to be concentrated in popular research topics where there was low skepticism and everything is accepted, like cancer treatment, non-coding RNAs, and certain topics of information science. That's kind of reassuring. Here are the take-home messages that you need to be cautious about what's published in journals, especially when those papers confirm what you already thought, and especially when meta-analyses and literature reviews are involved because of the garbage in, garbage out aspect. And ultimately, you can't even trust your own bullshit detector. Thank you, everyone, and I shall have another beer now.
Oh, Chris, you're on mute.
Of course, I'm on mute, Barry. Perhaps I'll ask Dr. Jones to set up his slides while I just have a few remarks here. David did suggest that he was available for questions, so I've directed people in the chat to put your questions in there, and if there aren't too many pint glasses in front of David's laptop in Liverpool, then he might be able to respond to you. That was very impressive, David, if you're listening. Moving on from David's quite impressive catalog and array of disciplines that he's delved into, Brian Jones is also going to bring a fair range of skills and topics. He has a very impressive CV in the abstract that he's presented. From a semi-retired psychologist, we're now moving to a fish pathologist who seems to be much more than that, a modeler, taxonomist, biosecurity expert. So we welcome Dr. Brian Jones. He's going to be talking to us about detecting more dodgy papers. There can't possibly be that many more, but let's hear from Dr. Jones.
So, detecting dodgy papers. You just see the screen and none of the garbage on it, I presume. So,
Yeah, that's right. Yeah.
I'll try and be quick. It's more or less on the same topic, but I want to try and cover some extra stuff. So why should publishing scientific papers be dodgy? How can you spot them? And what to do when you find one? Some of this has already been covered. But you need to understand that scientific publishers make a lot of money out of your work, and that's been brought up before. For Elsevier and Wiley, the return on the investment is around 40%. So they sell your papers and they charge you fees. It actually costs them about $150 to put your paper on the internet. The rest is profit. And so there's a huge incentive to get you to publish more papers because it's money in the bank. It's a $12 billion US industry. That's every year. It's right up there with drugs. So you've got to expect that people are going to take shortcuts. And they want you to publish as often as possible, special issues, new journals, discounts. And so you've got the rise of the so-called paper mills. They're not just appearing out of nowhere. They'll buy failing journals just to use their masthead. They'll clone real journals by using similar mastheads. So just be careful when you get on a site and say, yes, I've got a paper for sale, that you're actually talking to the journal that you think you're talking to and not to a cloned one. And it's the same caution you should use with when you do online banking. Have you actually got the right bank? Retractions are an issue. Closure of whole journal titles. About 20% of journals' papers are disappearing. Now, we talk about Hindawai removing whole journals. Not all of those titles were spurious. Now, if you are unfortunate enough to be on one of the issues that was, or one of the journals that was retracted or just closed down, your work is lost. And the other thing that nobody, as far as I can see, has touched on is that because of the huge amounts of money, it's probably being used for criminal money laundering as well. And so there's pushback. So Gates Foundation are refusing to pay publication charges on research that they fund. And the Swiss National Science Foundation won't fund any papers that you put in special issues because they flagged special issues as being a problem. So again, just be aware that within the publishing industry itself, there is turmoil going on because this pushback to avoid paying publication charges is affecting the bottom line of the publishers. So why do scientists do it? Well, to pad out CVs and support tenure, and people have mentioned that. To support research grant applications, to support a political and philosophical viewpoint. And there's a whole lot of stuff has come up, particularly in fisheries, around whether fisheries or whether fish are subject to pain. And there's a lot of the papers are being produced out of philosophy departments by people who've studied philosophy and who feel that fish should feel pain. And so they're producing papers, I guess, with the support of animal rights people to do that. But in fact, if you look at the science, there are sound scientific reasons going into neurophysiology as to why pain receptors are sparse or non-existent in fish. But that's, I guess, an unacceptable outcome. So there's a fight going on. And to support sales of drugs and treatment methods. And I'll give an example of that later on. So they contain false statements, manipulate false data. They may have fictitious references. They don't reference or discuss contrary findings. They may have fictitious or dead authors. If you're selling authorships and you need Western authors, why should you bother to actually ask the author? You can just stick their name on the paper, and the chances are that with the hundreds of thousands of papers that are produced every year, they won't notice. And if they did, well, that's even better. Sorting through them consumes an inordinate amount of research time, and they may be deliberately misleading researchers, politicians, and the public. So how do you find one? Well, it's easy. You find a citation on the net, you check the title. Is it relevant and believable? Check the journal. Is it legitimate? And check the publication. Was there actually time for a review? Check the authors. Are they real? Or is it a cat? And I put that in because just recently Retraction Watch found out that you can manipulate your H score by producing fake papers, putting them on ResearchGate. Google Scholar scrapes up the reference and gives you improves your H value. So they created a cat, well, got a cat, the office cat, created some papers in the name of the cat, and then got him a rather impressive H score. So check the authors. A lot of authors too buy their papers. Have a look and see if they're actually publishing in a consistent field. So most authors might be working on, say, cancer in rats. If they suddenly start producing papers on the quantities of stainless steel, you might start to wonder whether it's actually the same person. And authors institute some biases. Are they actually pushing a point? Are they a lobby group? Check the methods and the results. Are they sound? And check the references. Are they real, relevant, and findable? And one of the ways of doing, of selling references, if you like, is you can actually add extra references to the bottom. When was the last time, if you weren't actually reviewing a paper, that you checked the references were referred to in the text? So if you've got 20 references, if you put down 25 references, the chances are nobody reading it will notice there's an extra 5 references that shouldn't be in the paper. But the authors on those references get citation. So check the references. And just a caveat, this one tickled my fancy. It's a paper, Why Most Published Research Findings Are False. And they made a mistake in their in the formula that they were using. And they had to publish in erratum. So genuine mistakes do occur. This one, is this a legitimate paper? Global Trends of Reef Fishes, Ecology of Fear, Flight Initiation Distance for Conservation. Well, it's a strange title, but it was published in 2018 in Marine Environmental Research, which is a reasonable journal. This one turned up in 2023. The same title. The text is different, and the author, V.A. Braithwaite, is different. You'll also notice it was received on the 2nd of January and published on the 30th of January. So that suggests that it's dodgy. It's not had much time for peer review, despite the fact that it's been supposedly reviewed and revised very quick. But the killer is that Victoria Braithwaite died in 2019. So they're using the name of a very well-respected researcher to push and a title of a paper that's already been published to pad out a paper mill journal. The dates of submission and review are important. The more, I guess, established journals tend to have much longer article turnaround times than the paper mills. Rule of thumb is 80 days. If it's less than 80 days, get very suspicious. Of course, that doesn't apply if you're talking about preprints. But if it's gone through a formal publication process and is supposed to have been peer reviewed by 2 or 3 peer reviewers, you won't get it published in less than 80 days. Self-promotion. Live 52 is a herbal drug remedy for people with liver disease. It's available over the counter in New Zealand. If you look in the literature, you'll find there are glowing references to Live 52. Why we're not all eating it, you'd start to wonder. It's the best thing since buttered bread. This is one of many papers that's been produced in the last 20 years. You'll notice that 3 of the authors work for the Himalayan Wellness Company, which is actually the manufacturers of Live 52. If you go back into the older literature, around about 2009, you'll find a number of papers that point out that Live 52 is often associated with very high heavy metal content, and that the outcomes for patients that use it are negative. And if you produce a paper on saying the same thing today, and people have, they will be served with a writ from the company's lawyers, and the publisher will also be threatened with legal action for defamation. So here they have, rather than just withdraw their drug, they've flooded the market with papers that support the drug, and then they've taken legal action to make sure that anything that says the drug is no good is removed. They spend a lot of time and money on scholarships for scientists in third world countries, and it's out of those countries that these glowing reports come from. So you see, these ones are all from India, but you can find them from Nigeria and from Malaysia and from other countries in Asia. This is another one, avian influenza, H5N1, suggesting that it's actually a laboratory construct, just like the papers that came out with COVID-19, that people messing about with vaccines and gain of function have actually made H5N1 and released it from the laboratory. If you look at the foundation, McCulloch Foundation, the McCulloch Foundation was a foundation that devotes itself to anti-vax literature. So immediately you're going to assume that or I hope you're going to assume that with the authors all being members of the McCulloch Foundation, any paper that suggests that a disease is a result of vaccination is going to be suspect. When you get onto methods, this is an old graph, but it's a good one. Oldenburg after World War I, the number of stalks on the roofs of the new houses correlates almost exactly with the growth in population. There's a really good correlation, and it's used in many statistics books to show that correlation is not causation. The reason being that the new houses where the soldiers with their newly married wives were producing babies were also really good nesting sites for the storks. So both the storks and the people were having babies in the same houses. But if you look at the dots, you'll notice that the residuals have a pattern. It should not be a straight line. It should be a sigmoid curve. And that's a really quick, I guess, guide to whether the person who's put the statistics in the paper has actually got any clue about the statistics they're using. You will often find that because the computer generates a straight line, that they'll assume that there's a correlation. But if you look at the distribution of the dots, there is clearly a pattern. Check that they've used controls. An increasing number of papers that are produced have no controls, or the controls are not relevant. Do check the contents. Do the authors make claims that you know are wrong, or go against accepted explanations? Well, that's not necessarily wrong, but they need to have really good proof. And you need to be cautious about the paper.
Hi, Brian. Sorry to interrupt in this little interval, but just giving you a 5-minute warning.
Yeah, that's all right. I've just finished.
It's convenient.
What to do about it? Well, report it. Retraction watch is really good. And of course, for better science would be another one, or on PubPeer. But don't just file it in the bin, or as in this case, make a bonfire of it. Actually report it, because as has been said earlier, unless we actually make a stand, it's only going to get much, much worse.
Brian, thank you very much for that. Thanks to my awesome chairing, we're about 20 minutes behind. So people that have questions for Brian, could we put them in the chat, please? And then we can maybe have a discussion towards the end if we get back on track. Our next speaker, and thank you, Brian, also bringing us back to Epidemiology 101 and reminding us that we know some stuff about controls and how studies are supposed to be designed. That's all in our training. And those propose really good checks for how to deal with that. Our next speaker is Professor Andrew Gray, an endocrinologist. So we're getting all the disciplines here tonight. Welcome, Andrew. And he's going to be talking to us about the strange world of publication integrity. So our theme is thick with intrigue and fraud and mayhem. Carry on, Andrew.
Kia ora koutou, katoa. Can you actually see my screen? First question.
Yes.
Yes, we've got you.
Okay, cool. That's the first major problem out of the way. So thanks very much for asking me to speak. It's a topic that's of considerable interest in my academic work. We've been working in the field for about 11 years now. And thanks to the great Elvis Costello for writing songs whose lyrics resonate in daily life, because I think this is a pretty good example of some complicated shadows. So what do we mean? What do I mean by now I can't advance the thing? Sorry. Now I can't advance the thing, Patrick. How do I? Oh, there we go. So what do I mean by publication integrity? Well, integrity is the sort of concept that you know when it's there and you definitely know when it's not there. It can be a bit slippery to define, but it has connotations of honesty, wholeness, accuracy, and reliability. So when we talk about publication integrity, we mean the honest, comprehensive, and accurate reporting of research. And to produce, and I think there's nobody would dispute the idea that having a reliable scientific literature is extremely important. And a thing that's often ignored by the protagonists in this area is that actually the most important stakeholders are these folk, the public, and in my case, my patients, whose health is substantially affected by what's in the literature. And as you can see, there are a number of players that somehow come together to produce what we read in the literature. I'm not going to discuss all of these, but there are two really important groups. Obviously, the people who write papers are very important, and if they don't perform well, then that can compromise the integrity of what we see day to day in the literature. And really, really, really importantly, the journals and publishers, because they actually determine what is published, and they are responsible for what is, if you like, unpublished, corrected or retracted. And so they are a very central organization, and as others have already discussed, they profit enormously from this enterprise. And we think of publication integrity as a form, or assessment of publication integrity as really the quality control. So most industries, car manufacturers, for example, have robust quality control procedures in place. So what we're really talking about is quality control of the product of publishers. Unfortunately, publication integrity is very poorly scrutinized, if at all. And that may be changing a little as greater recognition of the many problems in this area become apparent, but it remains a major obstacle to the achievement of a reliable literature. And one of the problems that we see or think is a major contributor to that issue is that when concerns are raised about publications, and we've done this for several hundred papers now, those who are responsible for assessing those concerns, who are the publishers and journals and or the academic institutions, leap to infer that there's a problem with researcher behavior, that is, that there is researcher misconduct. And while it may be true that is the issue, but one of the issues or the cause for the problem, it tends to override the fundamental problem or the fundamental question, which is what much more important to the reader is this research reliable? That is, let's assess the publication integrity before we consider how that integrity was compromised. So putting the researcher misconduct cart before the publication integrity horse leaves a mess which you and I as readers are forced to deal with. Because not all problems in the literature are from fraud and from falsification, fabrication. There is a spectrum of behaviours and problems which can compromise what we see, and that ranges, as we tried to demonstrate in this cartoon, from errors, we all make those, through varying degrees of questionable research practices through to outright dishonesty, and therefore from the unintentional through to the intentional. And there are good examples of each of these problems causing compromised publication integrity. The problem is the problem's getting worse. It's hard to put a finger on how common compromised publication integrity is, but it's much more common than most people realize. And retraction rates, which are increasing, are a very crude metric for that variable, because I think anyone who's worked in the field would acknowledge that they are aware of lots and lots of papers which should be retracted or corrected or never been published in the first place, but are still there. So the retraction rate is very much the tip of the iceberg. Nonetheless, as you can see, those retraction rates are increasing over time. When you survey researchers from a variety of fields, as was done in this piece of work in the Netherlands a couple of years ago, some of the responses, so these are anonymous surveys, some of the responses are pretty sobering. So in this survey, 50% of the researchers, it's quite a big sample, acknowledged that they had indulged in what were termed questionable research practices, some examples of which are given in the top part of the table, within the past 3 years. And about 8% acknowledged involvement in fabrication or falsification over that same time period. So that's perhaps a slightly more fulsome estimate of the scope of the problem. The best estimate, though, I think, comes, at least for clinical trials, which are the mainstay of clinical research, comes from the work of John Carlisle, who was a sort of pioneer in methodologies for assessing publication integrity. He was an editor, I think he's no longer an editor at the journal Anesthesia, and he heroically took on the task of assessing the integrity of clinical trial reports at submission to that journal over a period of time, starting on the left-hand side of the graph with just the paper as submitted using so all he had was the summary data. And then as he realized that there were quite a few problems, he began asking routinely for individual patient data. That's the point of inflection there. And that the ability to examine participant data substantially increased the proportion of reports which he felt contained false data or to be fatally flawed. So about a quarter of the submissions to this one journal, when examined carefully, were considered to be fatally flawed, that is, should not be published. And I think his conclusion is very sensible. We should move from the idea that everything that is submitted by scientists is by default reliable, to the opposite, that all submitted papers should be regarded as potentially flawed, not necessarily because of misconduct, but because there can be errors and mistakes as well. And editors should review individual patient data before publishing, in this case, randomized controlled trials. Why do these problems happen? And we've heard already some of the discussion around that, and that's a big and interesting question. In our view, the weight of positive consequences from submitting and publishing unreliable research, be that for the individual researchers, their institutions, and the virtue signaling that institutions undertaking this area, and the publishers with their profit, well outweigh the negative consequences for any of those protagonists. And until we redress that balance, it's very likely that there will be an ongoing and substantial problem with the quality of research which makes its way into the literature. It's not a trivial problem, and others have already discussed this. In clinical medicine, there are any number of examples of serious consequences of flawed research. And one of the best examples many people will be aware of is the work of Andrew Wakefield, published in The Lancet in 1998, which associated use of the administration of the measles, mumps, rubella vaccine with the condition of autism. And it was fairly quickly questioned and fairly quickly shown to be flawed research, but not retracted, to the Lancet's shame, for 12 years, during which time vaccination rates in the UK and internationally fell, and there were epidemics of previously well-contained communicable diseases and flow-on effects into the schmozzle that happened around vaccination and vaccination beliefs in the COVID era. But one of the problems is that once the papers, even if they're retracted, once they're in the literature, it's really hard to reverse the adverse consequences. So here's a piece of work that we did where we examined the influence of 27 retracted trials in a large group of systematic reviews and clinical guidelines. These are the sort of documents that clinicians use to guide practice. And we judged that about half of those guidelines would have very different findings if those retracted trials were removed. So we contacted in a randomized fashion either the journals and editors or the authors and pointed this out to each party. And the striking findings were that in only about half of the cases did the recipients even bother to reply to our notification. And after a year, only 1 in 10 of those publications had any further scrutiny or notification that the original publication was flawed because of the inclusion of retracted trials. So prevention is better than cure, and this sort of downstream adverse effects are, I think, very, very prevalent. How does one identify flawed research? It's sometimes easy. You just read the paper and it's clearly nonsense. You can do it systematically. Now emerging tools which one can use. This is the one that we developed called Reappraised, which divides the assessment into 11 separate domains, which conveniently produce the acronym, and provides some guidance questions that one might apply under each of those domains. There are others similar, either being developed or now published. It's actually quite easy to find flawed research, as others have pointed out. There's lots of flawed research. The problem then, once you've identified it, the difficult bit is how do you go about addressing it? And because there is no robust system within the publishers and journals for addressing this, the onus currently falls on the likes of you and I, readers. So the system as it works or doesn't work currently is that readers who identify concerns communicate those concerns to the journals or the publishers. They often say they take advice from an organization called the Committee on Publication Ethics, which is conveniently publisher funded and whose staff, publisher staff dominate that organization. The journals might interact with the authors who may or may not respond at all. They may respond a bit. They mostly don't respond comprehensively or helpfully. Institutions may become involved and they may undertake some form of usually opaque and compromised assessment of their employees' works. And somehow out of that triangulation, there sometimes is achieved a resolution which is sometimes satisfactory in that it's addresses the concerns raised comprehensively and transparently. But in our experience, that outcome, that desirable outcome, is far and away the minority of resolutions. And here's an example of that from the assessment. This is how we got into the whole area, the work of 2 researchers in Japan, Yoshihiro Sato and Yun Uemoto, who currently sit 4th and 6th on the Retraction Watch leaderboard of most retracted authors. Are they published together or between them? 300 papers. Over 7 years, we forensically examined them, and by the end of 2020, we had notified concerns about each of those papers to all of the publishing houses and journals involved. But you can see that only about half of them did we get a response which indicated that any sort of assessment was being undertaken. Fewer still did we receive a response with the result, and not put on here, but a very small proportion was that response in any way comprehensive or detailed. And about 1/3 of the publications are now retracted. So that means that 2/3 are still out there in the literature, either unassessed or maybe they've been assessed. Maybe they've been ignored, I think mostly the latter, and it's extraordinarily difficult to believe that amongst that 165 publications from a group with now 135 retractions, there are not a substantial number of unreliable papers. So how can we improve things? This is a very broad brush. Readers, a key role to play. We should be skeptical from the get-go, even about our own work, in my view. We should separate integrity concerns from researcher behaviour. The primary question we're asking is this paper reliable? Not how it became unreliable, if it is unreliable. We can do systematic assessments. If you're going to do this work, you need to be resilient. It's good to do it in a group. You need to be persistent and thick-skinned, and you need to be prepared to be frustrated, dismissed, denigrated, insulted, and occasionally threatened. Journals and publishers are the central organisation. They need to be more sceptical. They need to separate integrity concerns from researcher behaviour. They need to undertake systematic assessments that are done starting early and signalled to readers, and they need to be comprehensive, transparent, efficient, and collaborative, including with those who raise the concerns that collaboration almost never occurs. And actually, they could reduce the number of journals. That would be really helpful. Institutions need to be sceptical about their employees' work. Even if that employee happens to be a distinguished professor, they should separate integrity concerns from researcher behaviour, and they should also undertake assessments which are objective, not in-house, comprehensive, transparent, efficient, and collaborative. And they could make a big contribution by de-emphasising the metric of quantity of publications, both for their own advertising about their own institutional excellence and for as part of the career advancement of their staff. We think that a useful contribution in the field would be the establishment of independent panels, which would be tasked with doing the work for publishers, which they currently almost universally fail to do well, just about finished. That would be available to the publishers, funded by the publishers, but independent from the publishers, since they're doing the publishers' quality control, staffed with people who know about integrity, know about research methodology, statistics, ethics, and are able to make efficient assessments of publication integrity, which they can then make available to the public and to the institution and publishers who are ultimately responsible for whether that research remains in the literature. Thanks very much for listening. I'm happy to take any comments or questions. And I'll stop sharing if I can. Stop sharing.
Thank you very much, Andrew. Yes, questions to the chat, please, for Andrew, for Brian, and for David. I think we've got the three of you hanging on. That was really interesting. Thank you very much. At this point, I will hand over to hopefully a better, more forceful chair, Tim Hopley. Tim, you on?
Kia ora, thank you very much, Chris. Ngā mihi, Peter, for opening with the Karakia. Thanks all for joining us today. For for the next session, which is titled Tales from the Frontline of Health Intelligence. And a big thank you for the speakers that have just been, and also to Chris for chairing, and for Patrick for working his magic behind. I don't know how you do it, Patrick, but thank you very much. To make up some time, we might just keep the questions to the chat. We might have to chew into the lunch break as well, pun intended. But we'll see how we go for time. Our first speaker today is for this session is Professor Shanthi Ameratunga. I hope I've pronounced that right. You're a senior medical researcher at PHONZ Ora. You hold honorary professor appointments at University of Auckland, Monash University, and University College London, with a work focusing on intersectional approaches to addressing inequities in child and youth health and trauma. Very interesting. The floor is yours.
Thank you very much, Tom. Kia ora tātou katoa. So I will get on really briskly and sort of it feels like the dark side of business now, because we've heard all about how challenging understanding integrity of research can be. But I'm going to basically talk about a data gap issue here relating to childhood injuries. I'm a pediatrician, as Tom mentioned, by background, and a public health physician. And the issues that I really I was confronted with as a training pediatrician was that often the children I would see for pediatric medical conditions at the Starship Children's Hospital, Kids First, would often be turning up a few weeks later for an injury, and something later, rheumatic fever, next bronchiectasis. And it seemed like we were seeing a very non-random population of young people who were increasingly and more inequitably at risk of various conditions, injuries being one of the most obvious, because it's the leading cause of hospitalizations for the childhood age group, and actually beyond the first year of age, the leading cause of death. First year of age, it's sudden infant death syndrome, or SUDI. Now, one of the things I also was conscious of was that when we look at the data and information regarding these children, we're sort of seeing it from a very fractured and in a sense, seeing lenses and seeing issues in a very unjoined, uncoordinated way. So I want to just use this presentation to think about things beyond the immediate to the long term, both in terms of determinants as well as outcomes. So my presentation is about what's the problem, what have we learned so far in Aotearoa with regard to the long-term impacts of injuries on children, what's the evidence from Victoria, Australia, and that's because I've been involved in a project based in that setting, and what are the implications for a model of care that can potentially address both the gaps and the invisibility, as well as the very likely inequities underlying the no data, no problem scenario. So just as a background, in looking at the global mortality trends across the world, injury is the leading cause of death for 10 to 24-year-olds. And as I've mentioned, in New Zealand, it is a leading cause of hospitalizations and deaths. And in countries, there's a good news part of this, in countries with advanced trauma care systems, and we can count ourselves among those, increasing proportions of children survive what used to be previously life-threatening injuries. What's problematic is we don't know what their long-term outcomes are. So we might be rescuing them from death, but what happens after? What we do know in New Zealand, using the available data from ACC and the health systems as we currently have it, is, and this is a publication in the New Zealand Medical Journal, is that Tamariki Maori and Pacific children are much more likely to have high rates of inpatient and day patient admissions for injuries compared to other New Zealand children. Tamariki Maori have the lowest rate of ACC claims. Now there's an inequity. We don't know why. You can guess at that. Maori whānau experience the highest proportion of loss of discretionary income. That is, they have to pay more for out-of-pocket expenses. And supposedly, according to ACC data, Pacific children have lower likelihood of documented post-injury disability. Now, this is basically how the data is depicting this thing. Something does not gel here for me, and I'm sure you would agree. Why should we, are we doing some miraculous things with Maori and Pacific children that makes them less likely to need ACC and less likely to be having issues of disability? And actually, however, just tough luck, they have to pay a bit more out of pocket. A couple of summer students that I worked with at Kids First Children's Hospital, Elijah Tuivaiti and Hemi Young, looked at with me at the data for New Zealand on long-term outcomes following injuries for children. What do we know about those and potentially about inequities? Effectively, what we found was there were about 14 articles. Most of them were looking at head injuries, not at all injuries. The Christchurch both cohort was probably the most influential in looking at the longer-term outcomes. Many of them, those studies showed that even with relatively mild brain injury, you can have quite substantial long-term social challenges with all sorts of adverse consequences for employment, education, and living. And there's minimal information on most of these studies on actually the equity impacts, because they're really not disaggregating data by ethnicity, age, gender, socioeconomic status. A qualitative study that we undertook now about 20 years ago showed that children, the families of Maori and Pacific children have disproportionately different experiences when they actually contact hospital services. And often they had difficulties with inadequate communication, information, they had difficulties negotiating the environment, and a lot of conflicting demands at home and work in relation to what their child was experiencing, and quite a lot of concerns regarding miscommunication from an sensitivity regarding ethnic issues. We asked service providers similar issues and how they actually saw the experiences for families of children who were admitted to hospital for injuries. And they actually said some of the same things, actually, that they expected. These were the concerns that were very similar. And the information needs not being met was a very obvious one. They'd had slightly different responses. The families wanted more people to sit by them and explain things to them. And the service providers thought we needed more pamphlets. Well, not pamphlets, but certainly more user-friendly documentation. Slightly different approaches to responding to the same problem. Now, we do know that there was a highly publicized media report last year that says, it's been mentioned that for major trauma, in fact, New Zealand is not doing terribly well, that our children are much more likely to die, twice as likely to die of serious trauma as the children in Victoria. Now, Victoria, State of Victoria, Australia is a space we can actually like to compare ourselves with. It supposedly has a model of care for trauma that's supposedly similar to ours, health system that's supposedly similar to ours. Why? We don't know the answer to this particular difference. However, I was already working with a group in Victoria, led by Professor Belinda Gabby, on an NHMRC funded project that was looking at the long-term outcomes of major trauma. And what that study, I'm going to briefly mention what the long-term outcomes for this study was showing for pediatric major trauma. About 200 children were followed up at 6 months, 12, 24, 36, 48, 60 months sequentially with a 71% response rate up to 5 years. And using some fairly well-established outcome measures and understanding the covariates that might explain what differences there might be, we looked at what those outcomes are. And the key findings, looking at the COSHI, which is the main disability outcome measure, is shown in this slide. At the top, the blue bar is showing the children who had fully recovered of that cohort. So by 5 years, 40% had fully recovered. The bar just below that is the relatively minor deficits. So they're pretty doing okay, but they might have some issues at school. They might have issues behaviorally, but not terribly problematic issues. But 40%, even at 5 years, had moderate to severe disability, as seen by the COSHI, which is an internationally recognized injury outcome measure. That's really quite disturbing. So although there is improvements across the 5 years, this is where basically most of these children were. This is children with major trauma. Now, when you look at their quality of life measures in terms of physical and psychosocial measures, what is obvious in the blue bar is that physical function is recovering virtually to the level of their norms for Australian children by 5 years. What is lagging behind is the psychosocial well-being. And that really isn't moving terribly much. And this is not unlike what some other studies have found. Now, you can imagine in terms of trauma services, surgical services, emergency responders, they're not necessarily seeing this view, and nor are they probably the most equipped to recognize what those consequences could look like and the social outcomes that follow, that the Christchurch cohort study was showing even with mild head injury. What we did notice was those adverse outcomes were predicted by information that could have been seen in the initial admission. Gender, older children had poorer outcomes, lower socioeconomic status, not surprisingly, children in regional and remote Australia, as in the state of Victoria, compared to urban children, comorbidities, compensable injury, that's a very specific issue in that some types of injuries are likely to get compensation, and that looks like a slightly problematic area where children with compensable injuries were having poor outcomes. Intentional injury, so this is less likely to be self-harm, this is more likely to be assault in this age group. Non-road traffic injury, the transport injuries got better support, and head injury, not surprisingly. Important that we did not see in this study admission to a major trauma service as being predictive of outcomes. Injury severity score, it's a threat to life score. It's not a threat to disability score. And any subsequent hospital admissions, pre-existing mental health or substance use issues, there were relatively small proportions of children there. They were not predictive of the outcomes. So the final implications of that study was that 40% of children in Australia, we don't have this information for New Zealand at all, but in Australia, 40% of children experienced moderate to severe disability even 5 years later, and the psychosocial outcomes lag recovery of physical function. And issues predictive of those adverse outcomes could have been seen at the outset during the hospital admission. This study did not have ethnicity data, and it did not really look at variations in care. And so we really have to look at injury in a way that looks across the continuum, and the data we tend to have in New Zealand is very much at the sort of preceding end and the emergency and immediate outcomes end, not where we might be really needing to look at if we're saving, as we should, more children with life-threatening injuries. So what are the implications for a model of care? Injuries in many ways is like a chronic condition. It's embedded within wider social injustices that made some children more likely to be injured in the first place. Impacts are not unlike the ACEs, which you might know the acronym, Adverse Childhood Experiences of Trauma of All Kinds. We do need to understand in New Zealand what are our local needs, contexts, and communities issues. And at least we can say, in principle, we should be looking at long-term whānau-centered approaches that align relationships with services, including ACC and primary care, align our data to take the long-term view and monitor the impact of early interventions. So this requires us to extend concepts and indicators in the data field, in the health intelligence field, of not just threat to life, but threat to well-being and flourishing of children. How we measure disability, not just as an impairment in the body or in the head even, but in the context that make those issues much more problematic because of inaccessible or non-enabling environments. We need to have mana-enhancing approaches to assess and respond to needs, particularly social needs, because it's very easy to get into the deficit framing by saying these are all deprived children, socially deprived families, and socially deprived communities. I think that can go down a very difficult terrain. Also, some of these families are hugely stressed and under a lot of trauma in a context like this with an injury. The last thing they want to hear is, okay, what else could you have done? And in the end, I'm going to unapologetically say in the current climate, we really need TDT responsive, equity-focused systems to avoid injuries in the first place and beyond the ER. I want to let you know that we are very fortunate to have got funded by HRC in a project that is going to look at the child injury outcomes over time. It's a mixed methods, qualitative and quantitative project that will engage patients, whānau, providers, and communities, led by Dr. Saini Taufa and with Dame Tawila Percival and others involved at Moana Connect and myself will be getting started on this beginning of next year. And I want to end by thanking the people who have made it possible. My email is there. Please get back in touch if you'd like more information.
Thank you very much, Shanthi. This is really interesting, definitely thought-provoking. It's nice to hear that you've identified the gaps and that you've got a project in place looking at the gaps and how we can improve them. Yeah, thank you very much. That was wonderful. Just a reminder, just any questions, feel free to put them in the chat. Kapai, thank you. Our next speaker is Giles Graham. Giles joins us from ESR, where he is a epidemiologist analyst in the health intelligence team. Interests include system and process improvements, flu tracking, the use of R to enhance surveillance analytics practice, and increasing team bicultural competency. No idea what that is, Giles, but the floor is yours. Take it away.
Kia ora, Tim. Just real quick, check that I am coming through clearly. Could someone give a thumbs up if you can hear me?
Yep, can hear you nice and clear.
He pai te rā. Tēnā koutou katoa, he mihi tuatahi ki tātua o te raki, mō te ora o te iwi au, tēnā koe. He mihi tuarua ki te kai karakia ko Peter Himona, mō te karakia, tēnā koe. He mihi tuatoru ki a Peter Himona anō. Koutou ko Barry Bowman, ko Patrick Hipgrave, ko Tim te me. Nā koutou I whakahaere te hui. Tēnā koutou. He mihi tō whā ki ētahi atu kai kōrero. Mō te māramataka. Tēnā koutou. A muri a tērā, he mihi ki a koutou e mātakitaki ana. Kua hono mai ai I tēnei rā. Tēnā koutou. Ko wai te riwai nei, no ko te rana au. E kāre he Pākehā au, a I te puaki I o te poti. Nā reire, he mihi ki a kapu ki taumahaka te mauka. He mihi ki a ofi o te awa. He mihi ki a kai tahu me ka te mamoi ka iwi. He mihi ki a otakau me puki te raki ka runaka o tēnei rohi. Tēnā koutou, tēnā koutou. He kai tātari tāku mahi mō ESR, ko Wastewater ARI Surveillance te kaupapa o tēnei pānui. Ko Giles Graham ahau, hoi anō, tēnā koutou. Tēnā koutou he mihi ki a koutou katoa. So my name is Giles Graham, and together with Joanne Hewitt, we will be talking to you about an evaluation of a pilot program for wastewater surveillance of influenza and RSV. Now, this could not have happened without the support of Imogen Evans, Andrew McNeil, Sarah Jeffries, Andre Rockmari, and Andrew Engelmeyer. So he mihi ki a rātou. Joanne will be taking over soon to talk about current wastewater surveillance practices overseas, and how we have already used wastewater surveillance and kind of how it is performed. And I will then take you through some of the local context of ARI surveillance in New Zealand, some formative details of the evaluation, and some of the things that we care about in the evaluation. Over to you, Joanne.
Thank you, Giles. Giles has already gone through the outline, so we can go to the next slide. So for those that don't know about wastewater surveillance, just thought I'd give you a very brief overview of what wastewater surveillance is. So there's a representation here of the practical side of wastewater surveillance using COVID as an example. So wastewater obviously contains multiple inputs from both domestic properties, but also from some animal input, such as slaughterhouses. But the majority of the output will be from toilets, showers, and other sort of liquid waste that goes into and makes its way to the wastewater treatment plant. So as long as a target or a pathogen is shed, mainly in urine or feces, it'll make its way into the wastewater treatment plant, independent of whether the person's got symptoms or not. So you can see on the right there, wastewater surveillance is used to monitor populations regardless of whether they've got any symptoms or whether they seek healthcare. So by collecting the water in the catchment, we can get a really good picture of what's happening to the community, or at least of those that are connected to the wastewater system. So to do that, we take a sample that's been collected over 24 hours, rather than just taking a grab sample. And then this is sent to the laboratory. And because water is a large component of the sample, viruses that might be in very low concentrations need to get concentrated first. And following the concentration, the sample can be analysed either by PCR or culture. So wastewater surveillance has been used for polio for decades as part of the global eradication strategy, and more recently has been well used for COVID surveillance. It's mostly used for sewage systems as described above, but this has been flexible where non-sewage settings have also been trialled, in addition to buildings and even aircraft. So as well as being suitable for polio and COVID, it's also proven to be suitable for other pathogens, including respiratory viruses and viruses that are mostly shed via skin shedding rather than through urine or feces, which was unexpected but welcome nevertheless. And it's been widely used from low-income to high-income countries, mainly low-income countries through their funding from funding bodies such as the Gates Foundation. So next. So these are the pros and cons of wastewater surveillance. Mainly pros, mainly advantages, with some disadvantages. Starting with the disadvantages, briefly mentioned that not everybody's connected to a sewage system, but even those that are not directly connected to a sewage system at home, maybe through work or through visits to places where are connected, like shopping centres, for example. It doesn't directly inform on the number of cases, so detections, generally you can't say, yes, there's 10 per 100,000 in this population at this time, or 10,000 per 100,000, but we can get information on trends. There's lots of advantages, mainly because it covers a large population, and as I've mentioned before, doesn't rely on health care seeking behaviour. It's very economical. Again, you can sample up to the limit of the funding, really. In New Zealand, we went up to almost 80% of the population at one point in time. It can address equity issues where other surveillance systems might not be covering that particular population. And for this, for flu and RSV surveillance, thinking about those and other pathogens that might have some data gaps, wastewater might fill those. And of course, data from wastewater surveillance can be used for other applications, including to input into modelling, for example, for hospitalisations. Next slide, please. So I'll just briefly mention about COVID surveillance. So when COVID first sort of emerged in New Zealand, the focus before the suppression and the status that we've got now, we had an elimination status where the focus on wastewater detections was unexpected detections, and to ensure that we were still getting negative results, so that could inform public health and also inform on going in or out of lockdowns, and that was done very successfully. You can see on this graph, this was during the period where this just followed the Delta outbreak that started in Auckland in August of 2021, where the majority of the sites in New Zealand, and we were looking at almost over 100, I think it was 120 sites at this point, most of them were negative, so no COVID was detected. And it was only until COVID sort of established following the Delta outbreak in the new year of 2020, where we saw almost 100% of sites were positive, and to this day that's the same situation. Next slide, please. So following the suppression phase. You can see from this graph here, there was hardly anything in the community until the beginning of 2022. It was more important to look at quantitation. So to do this, we could quantify how much SARS-CoV-2 was in wastewater and convert that to genome copies per person per day by taking into account the flow of the water and also the catchment population. Because we could do this and we needed a way to share it, an interactive dashboard was developed where the public and other stakeholders could look at both reported cases and the levels in wastewater. So as you can see from this, you can see where wastewater surveillance currently is trending, and it's trending away from the reported cases, as reported cases are no longer being reported in the same way as they used to. Next slide, please. In addition to trends, you can also utilize wastewater surveillance to look at a little bit more detail about the viruses that are circulating. In this instance, COVID is a really good candidate for looking at variants. This can be performed alongside clinical samples, and both wastewater and clinical gives a really good indication of what's out there. And often the emergence of these new variants can be seen in wastewater, but this obviously depends on the sampling numbers that are going through and being sequenced. Again, we don't need a person to get these results, so long as there's a good representation of the population. You can visualize this on a national scale, as well as on the left there at a site scale. Next slide, please. So we've not only been looking at SARS-CoV-2 and COVID surveillance, but because when the wastewater is collected and it's concentrated, you're not just specifically concentrating COVID, you're concentrating all sorts of viruses. So the same concentration, you can see there's a little, some small bars there, that's the concentration from half a litre of wastewater. That can be used for all sorts of different targets. So at the moment, we are also doing poliovirus surveillance. That's been going for 18 months now, where culture's used rather than PCR from important strategic sites that would inform on polio virus circulation that's going to be possibly not detected by other surveillance systems. It was also used for Mpox surveillance for a time during the emergence of Mpox globally, and within New Zealand, it was important to know that we weren't missing any Mpox. Also, AMR surveillance has been used overseas quite a bit to look at both influent and effluent and environmental surveillance of AMR. So for this rest of the talk, we'll be talking about influenza and RSV. So we carried out a trial where 2 samples a week were looked at from 7 sites. These were selected from the samples that were being collected for COVID. So the only difference was that a different PCR was being used. Everything else was the same. So pretty economical. Next. And I think this is my last slide. So just to give you an example of how wastewater surveillance is used for things like flu and RSV. So this is a couple of dashboards from the United States. One of them is the official CDC dashboard that was recently started in May. This is being used to look at flu A, and it's represented by levels, so from minimum to high, rather than sort of a graph of the quantitation. There's another example of another independent wastewater surveillance system, also in the States, at different sites, where on one dashboard they'll give you information on COVID, RSV, flu, and other viruses, including metapneumovirus and norovirus. So just so you realise that we're not the only ones, and this is quite well established overseas. So I'll hand you over next. We'll hand you over to Giles now, and he can talk about the evaluation compared to conventional surveillance. Thanks, Giles.
Kia ora, Joanne. Thanks for that. So, yeah, I'm taking back over to talk about how this interacts or could interact with our ILI surveillance. Now, a bit of quick background on our ILI is that most ILI diseases are not notifiable in New Zealand, and this makes surveillance different to a notifiable disease. So at ESR, we have multiple systems that work in tandem to give us a picture of the burden of illness on the community. And you can see a lot of them on the respiratory illness dashboard, which I've just got up here on the slide. It's another interactive dashboard. It's updated weekly over the winter kind of flu season. On there, you can read the interpretation of the overall state of ILI activity. You can check out the tabs that group the different kind of domains that we look at. And you can also filter and add highlights to the graphs themselves. Of course, I think it's a really rich tool. I do invite you to go look at it sometime. If you want to hear me shamelessly plug it some more, it'll also be part of the topic of my afternoon talk, and I invite you to have a listen to that when I give it. So you can think of each of the systems that we use as concerning different strata of the severity pyramid. So at the top, we have our severe acute respiratory illness sentinel surveillance. And just for time, I won't go into full explanations of each of these, but the severe acute respiratory illness, or SARI, is kind of the most severe end through Healthline, Sentinel, GP, virological surveillance, down through ARI and ILI outbreak and our flu tracking system at the kind of bottom of the pyramid of symptomatic cases. And then under that is where where wastewater surveillance could fit in, giving us information on both symptomatic and asymptomatic, as Joanne said. And Joanne mentioned some of the generalized benefits of wastewater surveillance. I wanted to reiterate a few that had specific relevance to our ILI surveillance. Of course, the relative economy of the system. That it's decoupled from health-seeking behavior means it won't be impacted by changes to accessibility of healthcare, which is a challenge we faced a few years ago with the GP sentinel surveillance, where we found it's really hard to take swabs over the phone. All right, so we're comparing against two data sources. One was the national minimum data set that's of hospitalizations, and it's really useful for its completeness, even though it's not considered timely for our particular needs of ILI surveillance. The other data source we used was the SARI testing adjusted rates for the respective viruses, both influenza and RSV. And because that SARI surveillance is limited to the Auckland region, we only compared against the data taken from the Auckland sites. So what sites did we pick? Well, had 4 wastewater treatment plants from Wellington, Parody, Christchurch, and Queenstown, and 3 interceptor sites in the Auckland region. Most sites we did select to represent New Zealand's largest urban centres. Queenstown we actually picked as a more transient catchment to see about detecting the cases associated with domestic and international travel. Of course, all of them are part of the existing COVID-19 wastewater surveillance system. So this isn't the first evaluation ESR has done on ILI surveillance systems. You're hearing about this one because I was part of it. I like to talk about myself. We based this and other evaluations, though, off the updated guidelines for evaluating public health surveillance systems produced by the CDC. Some of the attributes that we consider are timeliness. Any measure will tell us about the past. So timeliness considers the length of time between what we care about and between what we care about happening and when we have the final post-processing data set in our hands. And we seek to answer the question, with the delay between those two things, is the information still useful for our purposes? Like in the example of NMDS, it's for our purposes, the delay is too long. But for this, we included looking at the time between taking the sample, having the prepared data set, and the time between an individual becoming infected and shedding detectable amounts of the pathogen into the wastewater. Representativeness and equity we also look at. Both of these are assessed through looking at the sampled populations. That's the site catchment estimated populations. on the one hand, is it fair for us to extrapolate the results of our measurement to the wider population? On the other hand, is the information from this catchment population going to inform us about the prevalence of disease in the groups disproportionately burdened by ILI New Zealand, which is our Māori and Pacific populations? So sensitivity and specificity. In this context, sensitivity is whether an increase in the burden of the illness on the nation is reflected by an increase in our measurement, and specificity is the reverse. Does an increase in our measurement reflect an increase in the burden of the illness on the nation? And in our evaluation, we assess this via a correlation analysis. Of course, it's not exactly correlation, but it is what we used. And I do want to caution around using kind of correlation coefficients. You should only be using these to augment a visual comparison. If you can't already see a correlation from looking at the data, you shouldn't try to concoct one, which I guess particularly pertinent given the earlier talks. But finally, usefulness. So the goal of disease surveillance is to gain information that informs public health action. A goal of ours specifically is to make sure we're using our resources effectively to do this. Evaluating potential new surveillance systems, including when an existing system could be used to detect a new pathogen, in this case, is important to answer the questions such as, does it work? Is it economic? Will it support equitable outcomes? And will it give additional insight not already covered by existing systems? So in summary, Joanne has shown us how the system works and how it's already been useful. And I hope I've gone some way to explaining why we might want to use it for ILI surveillance and the importance of doing an evaluation to this end. So thank you all for your time.
Thank you very much, Giles, and thank you, Joanne, for your input into that as well. I wish we had time for questions, but if anyone does, feel free to put them into the chat and we'll try to answer them. Again, thank you very much, Joanne and Giles. Our next speaker is Dr. Matt Radford, who joins us from the sunny Hawke's Bay. Originally a GP, but has transitioned into the light side or the dark side. I'm not too sure which way you want it, into public health, and is very much interested in innovative solutions to solving health challenges, including surveillance. The floor is yours, Matt.
Does that, you can see my presentation? You can hear me all good?
Yep, looks good, sounds good.
Awesome. So kia ora. I'm Matt Radford, I'm a public health officer in Hawke's Bay. And yeah, today I'm talking about some of the use post-cyclone Hawke's Bay of pharmacy data to get an indication of illness, but also we have used it for many other purposes and see lots of potential for it as well going forward. So talk about that. I do feel a little bit after Ben's presentation from the UK, then a little bit like I'm talking about my kids' rugby team compared to the All Blacks or the White Ferns, Black Ferns. But anyway, that's where it could go. So this is sort of baby steps. So in terms of a little bit about me, it's me, my family on the right, with my 3 young kids. No tree was harmed in the making of that. That was Cyclone Gabrielle took out that, well, damaged that tree and that was cut down. Grew up in Ōtepoti, Dunedin, moved my way up the country to Wellington, and then had been in Hawke's Bay the last 10 years, where I've worked as a hospital and then as a GP for 5 years before moving into Hawke's Bay. So the Health Hawke's Bay, the PHO here for a year, and then the Public Health Service here in Hawke's Bay, and now at SINI here in Hawke's Bay. That's my role starting next week. So talking about Hawke's Bay post-cyclone, as everyone will be aware, Cyclone Gabrielle massively impacted New Zealand, and particularly Hawke's Bay was really hard hit. We had widespread flooding, and with that we had poor access to healthcare. Many bridges and roads were cut off, and it's just hard to get around and move. Napier was an island for many days. People come in and out, and for weeks to months for people in more rural areas as well. As you can see on the right, we've got a Redcliffe substation, which provides power for many areas of Napier, and Hastings was about 2 meters underwater. So we had power outages for sort of 4 to 5 days in the urban areas and weeks to months in more rural locations as well. With that comes like a number of health challenges. So particularly, it's just amazing. You just take for granted power until it's not there, and what it's there for as well. Particularly, fridge and freezers, keeping your food safe. On the left is all the food I had to throw out from our fridge and freezers. It's amazing how many condiments you have until you realize when you have to throw them all out. In the middle, we had like close living, thousands of people displaced, so living in close quarters and civil defense centers, and people having to live on people's couches, or even people that were completely homeless as well. Another major risk was all the silt and dust. There was estimated at least 10 million cubic meters of silt that came in Hawke's Bay with the flooding. On the picture on the right, East Valley, which was particularly hard hit, and it was up to sort of 2 to 3 meters of silt in places. So issues around respiratory, getting eyes and ears as well. So many health concerns. So we had it when I was working at Health Hawke's Bay, and also in close partnership with Public Health Service here in Hawke's Bay, thinking about how can we get an idea of what the burden of illness and see, particularly there might be increased illness from respiratory infections. So sort of having a think about what's there. It's got the standard notifiable diseases, which are sort of the robust gold standard sort of methods, although calculating small numbers and can take a while to come back in terms of lab results. People have to access their GP or hospital to do. Word of mouth was very helpful. We primary care, obviously letting us know if they see anything or hear anything from trends of illnesses, and health protection officers were in civil defense centers, so get an idea of what illnesses were there. But obviously that's just a small snapshot, and sometimes biases on what you hear, and you don't have that quantifiable nature. And obviously there's all the other data sets we mentioned as well, but often there is the hospital level data, and wastewater data really keen on and really awesome, but unfortunately for us, treatment plant was completely wiped out. So very helpful, but in another sense it wasn't. We couldn't use that information. So to have think about what data we could use, and one to help fill the gap was using pharmacy dispensing data. And this we had the support of ARI with us, been super helpful on this. So they do many things, but one thing is they deal with software and data support for pharmacies. So this data is already collected by many pharmacies across the Motu, and in Hawke's Bay, we're able to get data on 36 out of the 37 pharmacies here. So they take the data of, not just dispensing, so people have prescriptions and hand them and get the medications, but also if you go to the pharmacy and buy, some Codral, some throat lozenges, that's recorded as well. What we did is we provided a list, so having a think about what medications would people take to indicate a specific disease. To take, for example, gastroenteritis, if you've got that, you're vomiting, diarrhea, you might take some loperamide to slow down your bowels, or you might take some electrolyte sachet. So that gives an indication of the illness. And we did this for 14 groups of medications. They're not listed here, but it included prescription and also over-the-counter. Recare gets this data in real time. What they did is they provide that summary of that medication group initially daily, and later on, as there was less urgent need for it, it's been weekly, and it's been weekly ever since. And there's a large number of data. It's about sort of 15,000 medications being purchased or dispensed each week coming through. And then we looked at it at Health Hawke's Bay, and also in conjunction with Public Health Service as well. So this is one of the graphs of the overall numbers. So this is daily purchases or prescriptions for 6 weeks before and 6 weeks after the cyclone, with the red line being when the cyclone occur. Typical sort of M pattern of prescribing each week, where people run out of meds on the weekend and get them on Monday, or the GP is open on that day, reduces down the week, and then increases on Friday, and then drops down for the weekend when most of them are closed. You can see post cyclone pretty much was the week after was much less, and then it bounced back again for the next sort of week 2 and 3 after the cyclone. A little bit tricky to determine whether that was through just a rebound effect, so they couldn't get in and now they're getting the medications they would have got otherwise, or new illness. Looking more specifically, we can look at prescriptions. So this is looking at the various ones like antihistamines, cough and flu medications, reliever inhalers, and some antibiotics as well. Again, we see that drop during the week of the cyclone, and then it bounces back again. So this is slightly longer time period. So this is a year before the cyclone and a week after, and looking at weekly numbers. You can see some unrelated cyclone things. So on the left for analgesia and cold and flu, you can see some spikes which correlate with COVID. And then some, you might see on the right hand side, and just before the cyclone, some big drops. That's Christmas and New Year's, which is pretty much like a prolonged weekend in terms of access. Similarly, you see this is over the counter medications, a dip down and a rebound afterwards for the cyclone. Specific ones for medications, respiratory antibiotics, see quite a large increase the week after the cyclone. This may just be a rebound, but it is quite more than baseline. Another even more important finding, we'd see skin infections. So this is the blue over-the-counter and orange prescriptions. Again, we see, particularly in prescriptions, an increase in prescribing for skin infection medications for the next sort of 2 to 3 weeks after the cyclone. And it sort of fits in with what we saw anecdotally, reports of increased gastroenteritis, people getting skin infections from, and basically obviously lots of floodwaters and cleaning up, and in contaminated water as well. So it fits those other pictures as well. We are able to look specifically at the individual pharmacies themselves. So particularly one of importance is Bayview Pharmacy. So as you saw that photo of all the dust and silk, that was from East Valley. Bayview Pharmacy is the pharmacy closest to it. And pretty much if you're in East Valley, you'll probably go to that one because it's right next door to the area, and there's not any pharmacies close by as well. So this pharmacy, this is a shorter time frame, 6 weeks before and after. We see for prescriptions, again, a bounce, an increase in all sort of medication that's ceased for 2 to 3 weeks afterwards. But bearing in mind, there was an urgent medical centre set up and right next to Bayview pharmacies as well. So it's probably a mixture of increased illness, but also increased accesses as well. So some of the uses post-cyclone, but also used it over the last 18 months for many other uses as well. This is a graph over the last year for the cold and flu medication, and which is in the blue. The maroon is the number of pharmacies or dispensed from, but just for this talk, just ignore that one. But basically, you can see that in May we've had an increase in the number of cold and flu medications. So, for example, you go in and you got sore throat, and you get some. This one actually is more like, say, Codral or those type of medications, and so that increased up and then it's plateaued off, which is quite in keeping with what we're seeing from other surveillance data, for example, Flu Tracker or ESR's respiratory dashboard as well. Also used it and helpful when I was working at the Public Health Service for when we had a water exceedance. So up the top left, you can see, this is in the suburb of Taradale and Napier. You can see the 2 water reservoirs. I mean, a positive E. coli reported from the council, so we're quickly able to look at the yellow pharmacies. There's actually quite a few in that neighborhood, my neighborhood actually, and you could see that we can compare before and after the exceedance and compare it to other pharmacies in different areas, and we could see there was nothing of concern there. So that was just an example of a really quick way. Within a couple of minutes, we could get a grasp of are we missing something? How big is this problem here? And we could sort of reassure and decide how our level of response is as well. So, and it supplements all those other data sources we collected as well. So as I said, I feel there's a sort of baby steps, and it has lots of like future potential and can be built on and end up sort of something like we see in the UK. Some of the advantages, that real-time nature of it, all the pharmacy dispensing data is collected in the pharmaceutical collection, but typically that has been used for sort of research, and I use it for my dissertation. It's sort of years down the track, whereas especially for these urgent situations, that real-time nature is really important. Knowing now what's happening, you don't have to wait for a sample to come back either. And also gets that self-management population, which is real key. Like a lot of our data does come from hospital, and when you get that high severity, but it's good to get that self-management population where that wastewater sample from ESR is also looking at it as well. It requires minimal maintenance, so like it was very quickly set up because the data is already collected. It was just the Reki's end sorting out what the groupings were as well, and it doesn't rely on any ongoing input from patients. It doesn't require coding, so it obviously fluctuates with availability of pharmacies open, but less susceptible to how people code things or do anything else. Some of the disadvantages, and just bearing in mind that is a disadvantage of the current system, they could definitely ways that could be improved upon. One being there's no NHI level data, so it doesn't allow that subgroup analysis, which would be really awesome to particularly looking at equity in terms of looking at ethnicity data. Geographic data we have by pharmacy, which can give a general indication of where people are living in the illness, but it would be even better if we had by NHI, because that which is already on the script, so the information is already there. So you can get a more detailed idea about whether people are living where the illness is. You're thinking back to, say, for example, the water level exceedance, you can see the close by suburbs and match it up with the water catchment area. And it's over-the-counter medication from pharmacies, but we don't have non-pharmacies. For example, if you went to a supermarket, that wouldn't be included as well. Couldn't find any numbers on how much it represents, but it's probably a reasonable, I don't know, at a rough guess, it might be 50-50 in terms of over-the-counter purchases where they are. That would be a bit more challenging to get that information, given they're more commercial entities. And this is just a small point, but uncertainty on consumption. So you were assuming when they buy it that they're consuming it or taking it for that illness now, whereas some people might consume it later. For example, you might get some loperamide to take away on your overseas holiday, and also you might use one medication for your whole whānau, for example. Particularly the case it might be for like skin infection creams. You might share amongst your whānau. It's also really important just to get the size of the numbers we're getting through. So this is 2023, 6 weeks. This is the week of the year down the bottom, and this is 6 weeks before and after the cyclone. And the orange is the data we collected from pharmacy data. So solid line is dispensing, and the dashed line is over the counter. Then comparing it to what else we have in Hawke's Bay in terms of hospitalizations and also notifications. So this is the ones reported to the medical officer of health. So, you know, Campylobacter, salmonella, those sorts of things. As you can see, the numbers are way lower than what we're getting. They're sort of 20 to 30 times higher, the dispensing data as well. And hospitalization is probably an overestimate because it does also include abdo pain. So for example, with notifications, we sort of get 3 or 4, maybe 5 a week. So it can be affected quite subtly by how often people are reporting things, or, you know, 1 or 2 cases can change things. So the extra numbers helps determine that burden of disease. So where would I like to see go next? I think, and I've had some chats with NPHS nationally, but nothing concrete at this stage, but I'd love to see it sort of nationalized throughout the country. Particularly keys to improve it would be linking it to NHI, so we can look at that person data, particularly for like equity assessments and getting more detailed geographic information. Nice to have longer baselines. We've got about 2 years there, but if we had longer ones, we can see those more seasonal trends and know if any change is just a blip or statistical abnormality, or whether it indicates that it actually changed in disease status. And you could also add automatic detections into there. We used it mainly for surveillance, but I really see it as a multi-use tool. If you can put all medications in there, and then you could have certain ways of doing it. You might have a certain dashboard for surveillance, another one for assessment, another one for policy. You can do lots of different things with it. Particularly a key would be rapid evaluation as well. So any pharmaceutical change, you could see it within days to week, what effect that change in practice is having. For example, I can't do it with the current data set, but we do collect prescriptions that has age and community service cards. So if it was set up right now, you could tell whether the change in co-payment on prescription was having an effect on overall populations, and also by ethnicity as well. You could see and quickly change things rather than often evaluation longer down the track. So if you speed up that cycle, you can make changes quicker. Use it for medication adherence. Stock levels you could do, for example, during a pandemic, you could look at antivirals and see where they're being dispensed more than others, and then reallocate resources where they're more needed. Another really important one would be outbreak detection. So this is a graph. This is not available at the time, but this is RECARE's gone back retrospectively, looking at pharmacies that they have data from, and that looking at 2016 for Havelock North Campylobacter outbreak. Numbers are way smaller in terms of dispensing the but even there, you can see a very clear epidemiological curve for gastroenteritis medications. Again, remember that the bottom maroon one is the number of pharmacies dispensing it, so that the pharmacies are only a few recorded. So the notification to the public of the outbreak came in 5 p.m. on the Friday, but even on the Thursday, you can see increased numbers of dispensing. So you could have a basically threshold set and trigger warning if dispensing went above a certain number, whether by medication or by year, and then trickles off further evaluation as well. So overall, data is already there, but using it in a new and exciting way has been really valuable post-cyclone in Hawke's Bay to support other surveillance systems and manage response, but also multiple other uses that I've mentioned as well, and really excited about sort of the potential for expansion and improvement and how it can be improved upon. And I'd just like to end by thanking who's helpful. RECARE has been super helpful with their support and the data and their time. University of Otago with fellow researchers looking at running a journal article on the findings from post-cyclone at Hawke's Bay, and also to my workplaces at Health Hawke's Bay and also the Public Health Service. So thanks very much. And at the bottom is my email address, so feel free to contact me, anyone, if they want to discuss anything about it. Thanks.
Bye. Thank you very much, Matt. That's really interesting, and it's a sort of nice to hear, and definitely a useful tool for future situations, albeit I hope it's not another cyclone or anything similar. Cup, I thank you very much. I believe there is some questions in the chat for you, if you're able to answer those. And I believe we're just going to have a quick break and then come back at 12:40. Is that right, Patrick?
I guess that's all right. That will bring us nicely back on time. Since we're going into a short break, we've got one hand up from Chris McDowell. If you'd like to ask a question, go ahead. We aren't going anywhere for 10 minutes. You should be able to unmute yourself, Chris.
Oh, I actually didn't mean to put my hand up. I was trying to clap, but I do have a question. So sorry about that. So I was just trying to clap, but my question, I guess, for you, Matt, would be we've had some good initial conversations, I think, indirectly, especially through Dan Hurst, around the potential of rolling this out nationally. I was wondering if you could speak to the challenges of just even at a local scale of kind of like pulling the different data in from the different contributing pharmacies. How difficult was it to reconcile the data? Like, was it all in the same sort of shape and form, or was there some cleaning and work that had to be done? And then, if you could project that up to a national scale, what level of effort do you think it would be to roll it out across the motu?
Thanks for the question. Yeah, not fully sure in terms of I Riki deal with in terms of the sorting and cleaning the data, but from my understanding, relatively straightforward in terms of the data is already collected in a reasonable form. The time for them was more around the groupings and putting them together in a usable format. For example, when it started, from first discussions to being set up, it was a couple of days to do it. So, and then when we added in other medications and later, it only took a day or so, and so quite quick from there in that point of view. So I think obviously I don't fully appreciate how much what's involved there, but I think from a tech point of view, a modest amount of work. The thing would just be connecting up the pharmacies with Riki has data on many ones, but they're not on all of them. So that would be the major thing. The pharmacies were, most of them were set up, but a few pharmacies we had the clinical pharmacists had to go in and they just had to the pharmacy. They just had to change a few settings on their computers, which took a couple of minutes. So yeah, it was already there, ready to go. So not super knowledgeable, I think, in terms of work, not too much. The others would be more around the bigger challenges around data sovereignty and privacy and other areas as well to look at.
Excellent, thank you. Yeah, I appreciate that. Yeah, I found it fascinating looking at the Hawke's Bay dashboards for week to week, and then yeah, very curious to see what it would look like for if we had a national picture of that information. Thanks for your work.
Yeah, good question. Thanks, Chris.
Kia ora tātou ngā mihi ki koutou kia hoki mai ki te wānanga nei. First of all, thank you for that, Cherington. Thank you for all the previous speakers that have presented today. And really a good thanks to all our participants. I see the morning was a bit longer than what we thought it would be, but I saw that our numbers stayed at over 70 through that whole time. So I was very impressed about everybody's resilience. Now we have James Scarfe talking to us on the childhood scabies in New Zealand 2001 to 2023, an explanatory analysis. James is a public health analyst who has been working in the field for 10 years. He has authored 2 reports on behalf of Tohu Manawa Ora, the public health, on the topic of child serious skin infection, and co-authored another paper for the New Zealand College of Primary Health Care Nurses on the same topic. His other areas of interest include alcohol-related harm and the health impacts of air pollution. Giles hails from Rotorua and enjoys biking and taking with bikes in his downtime. I must talk to you about that sometimes, James, because I'm heading up to Rotorua in a couple of months to do some trails up there. Over to you, James. Thank you.
Yeah, hi. Hopefully my lighting isn't too bad. I'm on day 5 of isolation for COVID with the rest of my family, so I'm not in my usual space for the presentation today. So today I'm going to talk about an exploratory analysis of children admitted to hospitals with scabies and also community prescribing for permethrin for children. I guess it's got some interesting synergies with what we've just talked about. Sorry, I'm just struggling with there we go, I've got things working now. So I just thought I'd start off with a wee bit of background information. So what is scabies? Scabies is a skin infestation caused by the female scabies mite, with a rash often developing 4 to 6 weeks after infestation, spread by person-to-person contact. And scabies mites can survive in bedding and clothing without a human host for up to 3 days. The first line treatment is permethrin 6% lotion or cream, and then oral ivermectin. That's a legitimate use for ivermectin as a second line treatment, and also a treatment for crusted scabies. Severe scabies and scabies complications can require hospital treatment, and then to effectively deal with scabies infestations, you need to treat the whole household. But this can be quite tricky, and if not everything is done well, then you can end up with reinfestation. So I mean, how did this come about? How did this interest in scabies come about? So as it sort of was mentioned in my intro, we've been doing a lot of work on serious skin infections. So my former public health unit, Tohu Manawa Public Health, we'd set a goal to reduce childhood infections, and as part of this goal, we're monitoring a range of different infections, and one of those, we're monitoring serious skin infection in children. During that time, we produced 2 reports and a number of updates over the years. And so it was through this work that I became aware of something interesting going on with scabies. And I haven't seen it reported on elsewhere. So I thought this was a good forum to share what we've seen. So for this analysis, where the data was drawn from the National Minimum Data Set, pharmaceutical collections, and Stats NZ population estimates, also prioritised ethnicity population estimates generated by Stats NZ for the Ministry of Health. As I mentioned earlier, this data was gathered as part of a routine monitoring program of skin infections, and then I've updated this data for this presentation to include the post-COVID years. I drew on the O'Sullivan and Baker case definition for serious skin infection. I generated a serious skin infection data set for the whole of New Zealand from the National Minimum Data Set. And from this data set, I subsetted out the admissions that had a scabies diagnosis present. So all this data refers to children aged 0 to 14, and that's as per the serious skin infection case definition. The O'Sullivan and Baker case definition for serious skin infection has a number of exclusions. That includes transfers, admissions with a length of stay of 0 days, non-New Zealand residents, and people readmitted with the same primary diagnosis within 30 days. The 0-day exclusion is to account for inconsistencies in reporting of short-stay events that have occurred over the years. I've also drawn on initial dispensing data for permethrin 6% lotion and cream, and this data was from the pharmaceutical collection and it's for 0 to 14-year-olds. So unfortunately, data prior to 2007 is unavailable due to NHI recording practices prior to 2007. Okay, so I'll get into it. So the top chart shows the count of hospital admissions for children with a scabies diagnosis. The 4 colours represent the 4 regions. Orange is northern, grey is Te Manawataki, and yellow is central, and the blue is Te Waiponamo. Just to note this, so these are hospital admissions where the patient is diagnosed with scabies. It's not just the primary diagnosis. Clearly, these data are heavily weighted to the North Island. Perhaps there's a case for considering the North Island in isolations. However, I sort of went with the whole of New Zealand. And this may be, the weighting to the North Island may be due to climate conditions more favourable to scabies. So there's an increase in all regions in the count of hospital admissions, peaking in 2010 and 2011. The second chart displays the rate of hospital admissions with 95% confidence intervals, and we see the same pattern in the counts. So the rate increases from 2007 through to a peak in 2010 and 2011, and then returns to the sort of pre-2006 level. And then towards the end of the time series, we see the impact of the pandemic. In 2020 and 2021, scabies admissions to hospital with scabies start decreasing and then reach a low point in 2021. And now they appear to be returning back to sort of the baseline levels. So with that decrease there right at the end of the series, we're probably seeing the combined impacts of the lockdowns and social distancing recommendations playing out over the 2 years. So here I've displayed the data by 3 age bands. It's 0 to 4, 5 to 9, and 10 to 14. And we see a increase in the rate of scabies across the 3 age band, but it's much more pronounced in the 0 to 4 age band. However, the 2 older age bands did have a significant increase and peak in scabies admissions to hospital with scabies. But the peak for the older age bands is later than for the youngest age band, which is interesting. I'm not sure why that's occurred. In this chart, I'm displaying the rates of scabies hospitalizations by prioritized ethnicity. I've used the level 0 Ministry of Health prioritization scheme just due to the limited numbers of admissions in Asian and European ethnicities. This time series begins in 2006 due to the availability of prioritized ethnicity denominator that I had access to. On the left-hand side, I've displayed the data with a linear scale, and on the right-hand side, I've displayed the same data but with a log scale. Just because of the difficulty in seeing the rates for other. So I just wanted to see that if there was an increase, a similar increase for other ethnicity, and it appears there was. So that all the 3 ethnic groups follow the same, not the same, but follow a pattern of increase and then decrease. So the rate increase across the increase in rate is largest for Pacific children and then Maori children, and so we've seen a significant increase in the absolute inequality. So that's the difference between the rates there. Here I was interested in looking at the rate ratios or the relative inequality. The grey chart is showing Pacific children versus other, and the orange chart is showing Māori versus other. And so for Pacific children, we see the rate ratio increase and spike in 2014. This is in sync with the rates for Pacific children on the previous slide. So this represents an increase in relative inequality. For Māori children, we can't say there's been an increase in relative inequality, but that's, I mean, there's definitely an inequality present going by the rate ratio, and also there was quite an increase in the absolute inequality. that occurred over this over the period. Now I'll just move on to the community dispensing data. So of the topical scabies treatment, permethrin 6%. Just a note with these charts, there's two different scales. The bars are, the orange is the hospital admissions data, where the blue line is the dispensing data, the first dispensing data. So the bars go up to an order of 350, where the blue line tops out at 25,000. So what we're seeing is, as well as in the hospitalizations data, we're seeing an increase of treatment for scabies in the community at the same time. However, the dispensing data is offset slightly from the hospitalizations data. Now, I think this might be due to the perhaps the age makeup of who's being dispensed to. So the hospitalization data, as we saw previously, is heavily weighted to the 0 to 4 age band, where I suspect the dispensing data may be a more even distribution. And the older kids, they peaked slightly later than the younger kids. So that may be part of the reason for why it's offset. So there's an interesting plateau in the dispensing data from 2015 through to 2017. This coincides with the introduction of free GP visits for children aged 6 to 13, and the introduction of free prescriptions for children under 13. And then finally, at the end of the time series, again, we see a reduction during the pandemic for the prescribing of permethrin, which has since rebounded in 2023, back up to pre-pandemic rates. So I just want to, the data itself is quite interesting, and it's quite an interesting pattern that's an intriguing pattern that's occurred with scabies hospitalizations, and also the community dispensing of the treatment for scabies, the first line treatment for scabies. I just want to think about some of the things that have occurred of what may have contributed to the increase, and then what may have also contributed to the decrease in scabies, both in the community and in the hospitalizations with scabies. So right at the start of the significant increase, before rates jumped by about three and a half times, 2007 through 2008 was the global financial crisis, with the impacts on lower income households being felt for much longer. So this may have contributed to conditions that allowed for easy transmission of scabies. Also, at the same time, we had the steep increase in house prices in the early 2000s, leading to the situation being called an affordability crisis by the media in 2007. Again, this would have a disproportionate impact on lower income households. So both issues are impacting lower income households, potentially leading to an increase in both absolute and functional crowding. And again, there's sort of ideal conditions that could lead to a surge in scabies. Also, during this period, this is something my colleague often talks to me about, is between 2007 and 2012, there was quite a jump, about a 10% jump in live births for children. So this has kind of had a twofold effect. It sort of increases the at-risk population, but also it makes it difficult to account completely when you calculate your rates, because it's, with the 5-year age bands, it's not really adequately taking into account that sort of bump in the in very young children. However, I don't think this accounts for all the increase. it may account for some of the increase in the rates that we've seen. And of course, with the prescribing data, that would be sort of more evenly distributed across the full range, the full 0 to 14 range. Cool, I'm almost there. In terms of the decline, so from about 2011 onwards, there were a number of health interventions that may have contributed to the decline. So in 2011, after-hours visits for under sixes became free. This was followed by free prescriptions in 2015, and then the expansion of free GP visits to under 13s. So again, this was quite a significant increase in access to primary care, and particularly for a vulnerable group that can go downhill quite quickly, for the after-hours visits for under sixes. Also, during the period of decline in the rates, both of prescribing data and hospitalization data, there were a number of the rheumatic fever prevention program was active, and one of its components was a strong focus on addressing household crowding. Also during this time, there was a number of publications by O'Sullivan and colleagues around serious skin infections, and this led to a number of public health units monitoring serious skin infections and developing healthy skin programs that may have contributed to the reduction. And so finally, that I sort of alluded to in my abstract, can we was this an epidemic? I don't know. There was a sharp increase and then a decrease that looks a bit like an epidemic curve. There was a increase in inequality and inequity for this health outcome. But I guess the question is, was it more the social conditions and an epidemic of social conditions that makes it easier for scabies to thrive, or was it the scabies itself? Unfortunately, I don't have the answer to that. So that brings me to the end of my presentation. I hope it was of interest, and yeah, it was a bit intimidating following all those other presentations this morning, but yeah, I hope it was of interest, and I hope you got some benefit out of it. Yeah, any questions?
This is Peter here. James, we're running behind time, so I'm going to ask our participants to put any questions in chat, and maybe you can have a look at those in the coming minutes if you have time. About your presentation, I found it very interesting and very informative. I particularly liked your graphs. They were all pretty clear and you could see what was going on. And I thought you're dealing with ethnicity of the Māori and Pacific children. I thought that was quite sobering to see those higher rates here. Thank you very much for coming along and presenting to us. I hope you've got a couple of minutes to monitor the chat thing. If there are some questions, participants, please put them in there. But we have to move on now. We're running late, so thank you once again, James.
Right, thank you.
I can see Lynn is there. I'd like to welcome Dr. Lynn Riggs. The title of Lynn's presentation is The Relationship Between Multidimensional Disadvantages, Poor Health and Wellbeing. Lynn is currently a health economist with Health New Zealand, Te Whatu Ora. She has a wide range of experience conducting research both in New Zealand as well as the US. Throughout her career, Lynn has worked extensively with large confidential data sets. I've envied you. That must be a lot of fun, Lynn. And her interests are health, labour, education, and financial economics. Welcome, Lynn. It's over to you.
Thank you, Peter. Thanks so much for that wonderful introduction. Let me just go ahead and share my screen. Hopefully everybody can see that. Yes, so thanks to everyone for attending this presentation and for and the team for inviting me to talk today about the work that I've done in this area. And let's see. We do use data provided by Stats New Zealand. This is a standard disclaimer. The results are my own. These are not official statistics. They're based on tax data, but any limitations or weaknesses are really for statistical purposes and not related to the administrative function. Great. So just to give you a little bit of background, so this research was to support the Productivity Commission's inquiry into economic inclusion and social mobility. And the questions that I was trying to answer for them was, how do we define and measure disadvantage? And what is that relationship between disadvantage and relationship? And to really understand those relationships, you have to know what other factors play a role. And something that came up consistently in the literature was poor health, particularly in the well-being literature, as being a key component. So I'm going to focus on some of those results that we had. We don't have very much time today, but the paper's online, and we have lots of information in the online paper. So we used the General Social Survey for 3 years, 2014 to 2018. We had about 7,000 to 8,000 respondents per year. Respondents are 15 and up, but we focus on the ages 25 to 64. And we do that for a number of reasons related to our disadvantage measures. And again, more details about that are in the paper. But just looking at defining disadvantage, so we went to the literature, and one thing that the literature seems to agree on is that poverty is a basic and enduring cause of disadvantage. And for a long time, poverty measurement has predominantly been an income-based measure, but there's limitations of measuring income as opposed to wealth. There's limitations in setting the thresholds that can have you capture just poor. And so the way the thresholds are often set, it captures non-poor and also misses some of those people who are actually poor. So to try to improve those measures in the mid-1970s, researchers started turning to these non-monetary deprivation measures. So material deprivation is probably the most well-known of those, but social inclusion or exclusion also became pretty prevalent, even though that's a much younger literature than the material deprivation literature. And so as all of these different measures started coming about, people started, debating, should we use a unidimensional measure, so which would be just income poverty or material deprivation to measure disadvantage, or is disadvantage really multidimensional? So a lot of people started classifying people as disadvantaged if they're both income poor and materially deprived, or some combination of the three. There's a lot of different methods and a lot of different approaches, and this is really an evolving area. And so I hate to say we didn't have a lot of help from the literature on coming up with these measures, but we decided to use some of the traditional measures, but also to develop our own composite sort of multidimensional measures. And to do that, we use a principal components analysis. And we really started to think about this when we were thinking about, well, how would we put income poor, materially deprived, and socially excluded into the same regression, given how correlated they all tend to be. And so PCA, again, helps us develop some uncorrelated measures using indices, which we primarily use for our regression analysis. Because we don't have a lot of time, I'm not going to talk a lot about that. I'm just going to jump just kind of straight to the results. First, I'm going to tell you about my health measure. So we had a self-reported health status. And for those aged 25 to 64, we found that about 3% reported being in poor health. And so we use that as an indicator, primarily in our regression analysis, when we were looking at our results. Okay. And so this is just based on some of our initial results using some of the summary statistics that we developed from the GSS. So one thing that we saw early on was that as you increase the number of disadvantaged domains that we found someone in, we saw that the likelihood that they were going to report low well-being really increased. So for those people who had no disadvantage, about 12% of them reported low well-being. If we compare that to the group that, we saw on 3 domains of disadvantage, so income poor, socially excluded, and material deprived, about 55% of that group reported low life satisfaction. And so we see that there's this relationship, but again, we're just looking at summary statistics, and we wanted to dig into that a bit more. And so we used the PCA again to develop those dimensions of disadvantage. And so what we found was that we had a lot of measures or indicators that clustered together that we called going without. So being unable to afford going to a doctor, being unable to afford fruits and vegetables, to afford heat. So all of those things clustered together. We also found clustering of neighborhood safety measures, personal safety, labor market exclusion, poor housing, and also what we call not belonging. And that's not that people didn't belong, but people felt like they didn't belong. So they felt like they couldn't be themselves, they felt discriminated against, and also had feelings of loneliness. And so we use those dimensions in our regression analysis. So we use logistic regression to examine the risk factors for those traditional measures. And then we also used an ordered logit to examine the risk factors for lower well-being. So we had 3 measures of lower well-being, life satisfaction, life worthwhile, and family well-being. They pretty much track all together. So I'm going to focus primarily on life satisfaction and life worthwhile. But they're pretty consistent across all the different measures. And in this regression, we put those disadvantaged dimensions from the PCA as explanatory variables into the ordered logit. And so just to give you a summary of those results, we find that there's a couple of groups that are significantly more likely to be at risk of disadvantage and also of lower well-being. And those were sole parents and people with more distrust. And that was distrust not only of different types of institutions in New Zealand, but also of other people in New Zealand. And so we found that to be a really interesting result. We found really inconsistent results for disadvantage and ethnicity once we included other socioeconomic status variables. One thing that we did find, though, that was quite interesting was both Maori and Pacific were significantly less likely to report lower well-being once we included those socioeconomic controls. So that indicates that they actually have higher well-being if we compare people once we've controlled for disadvantage and, again, age and other things. So when we look at our well-being and disadvantage dimensions, what we found was that disadvantage does generally reduce well-being, and that going without and not belonging had the largest associations or the largest relationships or impacts with our well-being measures, and that the other indices, while significant, weren't significantly different from each other. And what this tells us is not only that there's a couple of different aspects of disadvantage, but that they are meaningfully different in terms of looking at something like well-being. And so if you really want to improve well-being, you might first focus on, that material deprivation aspect of it. And in terms of poor health, right, we found that poor health was significantly more likely, or people with poor health were significantly more likely to be at risk of both disadvantage as well as lower well-being. And again, it was pretty consistent across all of the measures that we used. So this was another group, in addition to the sole parents and people with more distrust, that came up consistently as being significantly more at risk. And so one of the things that you often see in the literature is people see PCA as this black box, though NZ-DEP is derived from a principal components analysis, and that's pretty widely used across New Zealand. It also allows us, like I said, to construct those uncorrelated measures so that we can put them into a regression and not have to worry about multicollinearity issues, which is also helpful when you really have some smaller samples and you can't just increase your numbers to try to take care of those multicollinearity issues. We also find pretty consistently that the different dimensions of disadvantage come up significantly over all the different ways that we kind of cut the analysis. So, you know, it wasn't, we did one analysis, we did numerous different analyses and basically had very consistent results across all of them. So there's some overlap in some of those traditional measures, like income poverty and labor market exclusion load together on the same index pretty consistently. But we're also finding not only that we have these other dimensions, but that they matter for something like well-being. And so again, you might focus on specific dimensions if you really want to affect something like well-being. And we also, again, found that poor health is really strongly correlated with disadvantage and lower well-being. And again, that's even on top of the other socioeconomic factors that might come into play in terms of both disadvantage and well-being. And while these aren't causal, they're still pretty consistent and significant across all of our analyses. There were some limitations in the measures that we were able to use, but again, we really did a lot of work to try to see how much our results changed as we changed the different measures, and we really found a lot of consistency across any way that we kind of did the estimation or the analysis. So as I said, there's a lot more details in the paper, and I'm happy to answer questions if people want to ask them. Thank you.
Thank you, Lynn. I found that really interesting. Two things that really caught my eye was I was quite interested to see those not belonging indicators, loneliness and other things like that. And of course, I was very interested. Of course, I was very interested to hear that Māori and Pacific were less likely to report low well-being after accounting for those other factors. So that was very interesting. We're making up time, Lynn. So yes, if anybody has a question, we can take one question live if you like.
Well, we've got a question from someone who just so happens to be the next presenter anyway, so I think they can have priority. Kaaren Mathias asks if there are any other international disadvantage composite measures using social exclusion or social connection components, and if you felt the way you addressed this covered that field of disadvantage adequately.
There are other measures and other analyses. Our results were fairly consistent with the international literature. For our social exclusion measures, we had to focus on, or we focused partly on some of the going without measures that were solely due to cost because we didn't have any other questions related to that. But for some of the neighborhood safety, personal safety, all of those things, we felt that we had included a fair number of factors that were relevant. We added in some more social exclusion measures when we just looked at 2016 and 2018. And again, the results didn't really change. So in 2014, there just weren't as many measures that were available in the GSS, which is why we had to limit the analysis to 2016 and 2018. But even when we threw in those extra measures, it didn't really make a change to the overall results that we found.
All right, thank you so much.
Thank you.
If anybody has any more questions, if you wouldn't mind popping them into the questions and answers, and perhaps Lynn, you can monitor that for a few minutes. Are we ready, Kaaren? Patrick, is Kaaren presenting live, or is she recording?
Yes, live. She's with us.
Oh.
Can you there? There we go.
Yeah. Kia ora.
Oh, so our next speaker is Kaaren Mathias. Her topic is the black box. How do frontline community mental health workers address health determinants and improve equity? So this follows on very well with Lynn. Kaaren is a public health physician and researcher whose specialisation is psychosocial mental health care. I hope I said that right. Her career has primarily been as a practitioner and has spanned across positions working with Canterbury DHB, the Emmanuel Hospital Association, and other non-profits in India for a number of years. Currently at the University of Canterbury, Karen's current projects include examining the assets for mental health care in communities, youth mental health care research priorities, and lived experience in mental health service design and delivery. Welcome, Kaaren, over to you.
Kia ora, thank you, Peter. And kia ora koutou, ko waiau, no tamaki makaurau, no patararu ahau, ko o te tahi tōku kāinga inaine, ko Kaaren tōku ingoa. And interesting to be talking about black boxes when we've just heard about that from Lynn as well. I'm sharing information about projects I've been doing both in India and Canterbury, and I think I'll talk about why I think this is useful for us to think about in Aotearoa. So just as a background, task shifting is an idea that has been gaining traction globally, and it's basically the idea that things that professionally trained health workers have done can actually be done well by non-regulated workers. And we've seen this in some of my areas, particularly mental health. And we've seen that, for example, Matt Ducey announced earlier this year that rather than funding a whole bunch more of clinical psychologists, they're going to pay for peer support workers in emergency departments. There's been a big contract for brief intervention talk therapies across primary care in Aotearoa. That is more with trained professionals, but not necessarily all of them fully regulated clinical psychologists. And so, and this is something that has been done in low-income countries for decades. And so it's kind of new to New Zealand. And there's lots to like. It's particularly popular with politicians and people who watch money, but it's also interesting to say people who provide care in communities are often able to do things that perhaps professionals don't do so well. And so this research is sort of saying how we know, for example, that 80% of health outcomes are determined by factors outside the health system. We know that we need to address social determinants, and we don't do that adequately in most clinical settings. And so this focus, and particularly in this research, was how are health workers, unregulated, not professionally trained, so lay counsellors, we could say, how are they promoting and improving mental health and addressing health determinants? So what are the strategies? So this is a picture of me. I've worked for 15 years in India earlier on in this century, and I just find so many fascinating connections between research and work in India and in Aotearoa. I'll talk more about why we use data from both places en route. So the setting of these were two research projects which have converged because I found lots of convergences. The first one was set in Christchurch. I was working with Annabelle Ahuriri Driscoll and others, and we were examining the strategies used by frontline health workers to increase equity in child health outcomes. And these are the three organizations we're working with. All of them were non-profits. And in India, I was examining a non-profit organization who are one of the leading mental health providers in Uttarakhand, a state in the north. And I think many people are familiar with Christchurch. It's a sparkling, frosty winter's day in Christchurch today. And Uttarakhand is a hilly area. It's got some 7,000 meter peaks, and it's also got some very dense cities with very poor air quality. So what were the health workers doing? In Ōtautahi, in the three different organizations, we mostly were looking at health workers working with children and families. They were often supporting well child whānau ora type programs. They were mostly visiting people in homes, and most of them were non-regulated providers, but a few were social workers. In Dehradun, the city in North India, it was a high school graduate, nearly all women. There's lots of gender issues around. It's a very women-dominated role in both Aotearoa and in India. And providing psychosocial support, so counselling, support groups, motivation, reflective listening, as well as trying to connect people up with resources in their communities. So this was a qualitative study, and I know that a lot of the presentations here have been quantitative, so hopefully you'll bear with me and recognise that the value of qualitative research too. We talked mostly to whānau and kaimahi, so people who received care and delivered care in Christchurch. And in Dehradun, we talked to the health workers themselves. We were interested in how did people construct and understand what were the social determinants of mental poor health? How did they engage with those? What changed? Did things get better? And what were the ways that they engaged with social determinants? We used inductive coding for both the studies. The Christchurch one used a reflexive thematic analysis, and the Indian one was qualitative content analysis. So I wanted to share today 3 key findings, and I think they're really relevant because we're interested ultimately as people who work in health and how do we change the big picture? And frontline health workers are doing some really awesome work that are really changing the structural determinants of health that we just heard about from Lynn. So one of the biggest things that unregulated providers were often able to deliver was their own deep knowledge of a local context. In both places, in Christchurch and in the city in North India where we did the study, they were often resident in nearby or the same communities. They had long-standing relationships, and that meant they really understood what were the social factors that were influencing. So I remember this example, just walking along with a community health worker. We were going to visit a person who was mentally distressed in their house. And the health worker, I was like, so tell me what's the deal? What's this got happening with this person? And with no notes or anything. And she's looking after 20 or 30 people each week. She said, Deepak, he's a 20-year-old. He's originally from a Sikh group, dropped out of school because his family was migrating for work. he was doing okay at school, but he dropped out a couple of times, and it was made worse when his dad and uncle went to prison. And he started an apprenticeship that also didn't go so well. And he's actually really, really struggling and just doing random work, a bit like in New Zealand, picking up some lawn mowing here or just struggling to get work. He's really self-doubting. And then she talked about, there's a whole lot other more conversation, but talked about her understanding of his family and of his community and all the factors of having been a migrant labourer, which impacted his ability to be mentally well. But then said, well, we formed a group with some other young men. It's an example of a group like that was run in the community, and it made a really big difference. And it was very much linking to his ability to form social connection and find a social place of belonging. And so it was really interesting because these are skills that you wouldn't necessarily get with a one-to-one clinical psychology, CBT type intervention. The second thing that came through really strongly was the importance of relationships, and particularly in how they act almost like a springboard that other things jump off. And I presented about this at the last PHONZ Conference, and it just seems so core to so many health outcomes. One of the biggest things that came through in both study sites was the importance of a feeling like the person you're meeting up with is like me, and they're, in this example here, it says they're kaimahi, but they're also family members, mothers, sisters, grandparents, and it's kind of real. And that's quite a good way to break through the walls. And this mother was talking about the barriers that typically exist between her and health providers. And so this whole idea of relationships was really key. A young man who I met up with talked about why, I was asking him why it works so well for him to meet up with a young peer counsellor. And he said, well, it's basically because he's been through the same stuff. And I'll ask him, how did you manage to cope? One of the things that was really interesting that came through in our data was that relationships were caring rather than transactional. So it wasn't about, we've got a service delivery agreement, you've got to do this, this, and this and we've got to tick this off in the box. But they were more like, what do you need? What will help you move forward from where you are? And so one mum in Christchurch told me how the health worker had spent ages with her daughter, helping her get, as a teenage daughter, she got her license. And then she just was so much better and more engaged with her asthma meds, having been someone who was really out of control with asthma, and that the health worker dealing with her driver's license, which is, a real determinant of health, then led to the health outcomes. And so the third thing that we found was that there was the in-depth knowledge of a family and how the family worked, so which built on these relationships, was really core to them making micro adaptations. And there were some really great examples. For example, a young woman in India who was very depressed. Postpartum depression would be what a lot of people in New Zealand would call it. She was able to find a sewing group in the area where there were some other young women who were also new mums, get them together in a sewing group, and that turned this woman who hadn't left the house for 3 months, got her going out and really made a difference. And so that sort of understanding of local resources. And I guess, of course, these three really work together in a sequence. It's not one thing or another. You have a local contextual knowledge, you have a strong relationship, and then you can make the bespoke adaptations. So just as I start to wrap up, I think it's sort of really important to think about these things all sound really reasonable and make sense. But I think typically when we're providing healthcare, where we're designing health contracts, we don't give the space and recognition of those local contexts and understandings and ability to address determinants of health. Although although people have recognized the sort of economic value of non-regulated lay counsellors, and in New Zealand that's happening too, the possibility that they offer a care that is not actually, they offer something different to what you get from a professional, which is really tightly linked to their own living setup and engages with the sort of an endogenous solution is really important. And so I guess that there's the paper that I've got, which I'll show shortly, discusses in more detail about how we could think about designing healthcare that really engages more with the local, more with the amazing knowledge and value that people with lived experience contribute, and also that people who, I guess, of unregulated unregulated carers who know the setting really well. I also just found this really interesting as someone who's from New Zealand and has lived many years in India, just sort of saying there's lots to learn across things. And I guess that maybe part of us on our own decolonizing journey, that maybe some of it is saying what's working well in other low resource settings. How do we do a better job in New Zealand of listening to and saying there's things for us to learn from low income settings? So yeah, that's me, and thanks for your time. And if you're interested, please do jump on. This is an open access publication. Be really interested in your thoughts. Kia ora.
Tēnā koe, Kaaren, ngā mihi kia koe. I find that very interesting. It was kind of like different to what I'm used to, and the point that I got that was most interested to me was the value of local communities by local experts and not necessarily professional opinions. Thank you for that. Do we have any questions?
Nothing in the chat, Peter.
Okay, thank you once again, Kaaren, and all the best with your work. Our next speaker is here, Bernadine Williams. The top of her presentation is the wellbeing of children in emergency housing motels, service providers perspective. Bernadine is a health advisor currently at Massey University. She has over 30 years of experience in social services, a background in psychology and communication. She has expertise in disease prevention and mental health insights. She is committed to fairness and accessibility in the support of public health initiatives, extending across government agents, non-profits, and community groups. Outside of work, Bernadine cherishes time with her supportive husband, 3 children, and border collie. Welcome, Bernadine. Over to you.
Kia ora whānau. Thank you for having me this afternoon. I am just going to share my screen. Can everybody see there?
Yep.
Perfect. There we go. So, kia ora e te whānau, ko Bernadine toku ingoa, ko Chapandika te whānau no South Africa aho. I have just recently graduated from the Massey University with my master's in public health, and my thesis and the focus of this presentation today will explore the critical need for comprehensive support services for children residing in emergency housing motels. In New Zealand, high rates of homelessness exacerbated by historical underinvestment in housing and the COVID-19 pandemic have led to a reliance on emergency housing, primarily motels. The short-term solution intended for urgent situation often lacks adequate facilities and adversely affects children's health and well-being. When a household finds themselves in a situation where they have no accommodation, they can test their eligibility through the Ministry of Social Development's Special Needs Grant for emergency housing accommodation, which is usually a motel. This research was conducted over 2022 and 2023, with data being collected in early 2023. For the month of March 2023, there were 3,375 children residing in emergency housing motels, and the New Zealand government had spent in that same month $29.7 million. The Waikato region has the highest number of households residing in emergency housing. Albeit the definition of emergency housing, specifying it being short-term accommodation, in March 2023, 597 households resided in emergency housing for 3 to 6 months, and 678 households resided in emergency housing for 6 to 12 months. Maori were overrepresented in emergency housing, with 63% as the primary applicant, 35% New Zealand European, and 12% Pacifica. 41% of households requiring emergency housing were single parents with dependent children, and 8% were couples with children. This data highlights the fact that there is a significant percentage of whānau with children residing in emergency hotel settings, and this informed the focus of the research. The study was conducted in Hamilton City, Waikato, New Zealand. 10 participants were interviewed either virtually or face-to-face, and each interview varied between 30 to 60 minutes. Participants were from diverse backgrounds, including education, health, and community services. Thematic analysis yielded 5 themes, providing rich insights into participants' experiences. Theme 1, living conditions. Today, I want to share with you a glimpse into the reality faced by families living in emergency housing motels here in our community. Imagine being crammed with your entire family into a single motel room meant for just 1 or 2 people. It's not just crowded, it's often damp, moldy, and sometimes described as filthy or even disgusting by those who visit. Families in these situations lack the space and facilities they need for daily living. Basic things like cooking a meal or finding a quiet space to do homework become major challenges. Service providers who work closely with these families witness firsthand the impact of such living conditions. They see children struggling with health issues like head lice, school sores, and respiratory infections, all exasperated by cramped living quarters and poor hygiene. What's more heartbreaking is that many families end up staying in these motels for much longer than anyone anticipated. Months pass by in unsuitable conditions that are far from ideal for raising healthy children. I recall one story shared by a participant about a child who had lived in multiple emergency housing motels on the same street. A stark reminder of the instability and uncertainty these families face. Service providers are doing their utmost best to provide support to these families, often going above and beyond their duties to meet urgent needs. From arranging food parcels to securing essential cooking appliances like electric frying pans, they strive to alleviate the challenges these families endure. Yet amidst these efforts, there's frustration and concern. Many participants voiced their worry that these living conditions contribute to health inequalities and hinder child development opportunities. It's a situation that doesn't align with the core mission of the organization to promote the physical and mental well-being of children and ensuring they have access to essential health care. Every child deserves a safe and stable home where they can grow and thrive without the constant threat of inadequate housing. Theme 2, physical and psychological safety. Imagine being a child in such a place, where your everyday environment is shaped by the unpredictable and sometimes unsafe behaviors of neighboring adults. Families in emergency housing often find themselves living in close proximity to others in similarly distressing situations, whether it's substance abuse, gang involvement, or simply severe overcrowding. The physical layout of these motel complexes can inadvertently create an environment where children are exposed to risks, both physical and psychological. Parents, understandably, concerned for their children's safety, often feel compelled to keep them confined within the motel room, limiting their ability to play freely or socialize with their peers. Service providers who work tirelessly to support these families face their own challenges. They often express deep concerns about the safety of children in these environments, but struggle with uncertainty about who to turn to for help. It's a heartbreaking reality that some children may witness inappropriate behaviors or experience trauma that manifests in behavioral issues at school or in social settings. Moreover, these families can be transient, making it difficult for service providers to maintain consistent contact or provide the necessary support. The lack of continuity can lead to children falling through the cracks of our system, missing out on critical interventions that could safeguard their well-being, particularly in cases of family violence or other emergencies. These vulnerabilities cannot be ignored. Every child deserves to grow up in an environment that fosters their physical safety and nurtures their psychological well-being. Theme 3, barriers between service providers and whānau. Service providers dedicated to support families in emergency housing face significant challenges in maintaining contact with their clients. Frequent changes in contact details mean that when services are available, reaching those who need them most can be frustratingly difficult. Healthcare, while crucial, often takes a backseat for whānau, grappling with immediate needs like securing food and safe shelter in emergency housing. It's understandable that these necessities become the top priority when families are in crisis, potentially leading to missed opportunities for important health interventions through the public health system. Behind these challenges lies another barrier: resources and funding. Many service providers highlighted the struggle to secure adequate resources to meet the diverse needs of the families they serve. Limited funding restricted the ability to provide comprehensive support, exacerbating the difficulties faced by whānau navigating complex and stressful situations. Yet, amidst these barriers, service providers persevere with dedication and compassion. They recognize the importance of holistic care, addressing not just immediate needs, but also promoting health and well-being across all aspects of life for their families. Streamlined systems are needed, which ensure essential services are accessible and responsive to the changing needs of whānau. This means addressing funding gaps and enhancing collaboration between services to provide integrated support that meets the holistic need of these families. Theme 4, collaboration between service providers. Despite the aforementioned barriers, participants played various roles in ensuring children in emergency housing motels were supported. This included creating programs to support and promote child well-being. Participants often tried to liaise between organizations and work in collaboration to support children in emergency housing, but this often proved to be challenging. A local school appeared to be taking a holistic and proactive approach to supporting students who are in emergency housing, emphasizing relationships, cultural sensitivity, community collaboration, and innovative educational and support programs. Examples of these include funding for a social worker and school counselor to provide pastoral care, funded after-school care programs, alternative discipline approaches, and evening classes with meals. These efforts are geared towards not only academic success, but also the well-being and positive development of each student. Lastly, theme 5, motels as a site for supporting whānau capability. In the effort to support families residing in emergency housing motels, participants have proposed transforming these spaces into vibrant community hubs. By utilizing existing facilities such as conference rooms, these motels can offer a wide array of essential services directly on site. This includes practical support like budgeting advice, employment assistance, and upskilling courses, alongside enriching activities such as cooking lessons and health checks. Centralizing these services at the motel not only reduces barriers to access, but also creates a supportive environment right where families live. One standout example is a school holiday program that empowered children through activities like cooking, echoing cultural traditions. By involving children in familiar activities like preparing fried bread and boil up. The program fostered a sense of community belonging and pride in cultural heritage. The focus is on holistic care, aiming to support not just children, but the entire whānau. This approach is seen as pivotal in relieving pressures on families facing multiple challenges, making critical services readily available. Furthermore, initiatives like surprise visits from an ice cream truck illustrate how simple gestures can create lasting memories for children, promoting moments of joy and normalcy despite difficult circumstances. By envisioning motels as more than just temporary shelters, but as hubs for community and support, participants hope to empower families to improve their circumstances proactively. This not only enhances children's well-being, but also seeks to influence mindsets within whānau, fostering resilience and capability building for a brighter future. However, it is crucial to acknowledge the limitations of motels as long-term housing solutions. While these ideas aim to enhance family capabilities, they underscore the need for sustainable housing solutions to truly support families in need. Imagine a child full of curiosity and potential growing up in Hamilton City. They should be in a place where they feel safe, where they can build friendships, and where they can dream about their future. Unfortunately, many children in our community are spending their childhood in emergency housing motels, intended only as a temporary fix for homelessness. These motels, originally meant for short stays, have become long-term homes for those children and their families. The situation not only highlights a glaring inequity, but also poses serious challenges to their well-being. Children living in these motels face inadequate living conditions, uncertainty around meals, disruptions in their education, and even risks to their safety. It's a stark reminder of the barriers they face just to have their basic needs met. As a community, we must prioritize their health and stability. Organizations are working tirelessly to support these families, but they face significant hurdles. They're advocating for tailored health services, better education support, and safe spaces for these children to thrive. Building trust between service providers, whānau, and motel managers is crucial to delivering effective care and support. We need innovative solutions. Services like healthcare and nutrition support should be available right where these families are staying, in the motels themselves. By utilizing spaces like school halls or conference rooms, we can create environments that are conducive to learning and growth, while also reducing the stigma that often accompanies receiving help. Ultimately, though, we need systemic change. Emergency housing should be just that. Our goal must be to ensure that every child has access to stable, permanent housing. This isn't just about today, it's about their future. Every child deserves the chance to settle, belong, and flourish in their community. The thesis is available on the Massey Library, through the Massey Library, if you are interested in further reading. I also want to take the opportunity to thank Dr. Linda Murray and Dr. Bevan Eruiti, who were my supervisors through my research journey. Kia ora.
Tēnā koe, Bernadine, ngā mihi ki a koe. You spoke very well. I found that talk very sobering. You highlighted a lot of the problems that we have in emergency housing, and I was pleased to see that you offered one or two solutions as well, or opportunities like training and things like that. And probably overall, it helps to remind us what we're all doing working in health, and that we have a lot to be thankful for. Thank you very much for your presentation, Bernadine. Do we have any questions?
No, it doesn't look like we do at this time.
Thank you once again, Bernadine. We'll move on now, and if anybody has any questions or thinks of something, pop it in the question and answers, Phil. Now I'd like to welcome Francis Arnhold from the Heart Foundation. Francis is a New Zealand registered dietitian with over 10 years public health experience. Over the past 5 years, Francis has been working with the Heart Foundation on school and early learning program and project improvements and resource development. Welcome, Francis. Over to you.
Kia ora, Peter. I'll just make sure everyone can see that. Kia ora koutou. No arena, koturana, horana, o kutupuana. I tupu mai au I Atelia kei papakura ahau e noho ana. No reira ka mihi au ki te maunga puki ki riki me te awa o pahurahura. Ka mihi hoki kai te hau kainga o kene ko Arnhold toko whānau, ko Francis toko whenua, kei Heart Foundation ahau e mahi ana, he dietitian ahau. Good afternoon, I'm Francis Arnhold and I'm speaking to you from Papakura in Auckland. And my descendants walked me here from Ireland, Scotland and the Netherlands, but I grew up in Australia. I acknowledge the mountain of Pukekiwi and the river of Pahurahura. I also acknowledge the people of the land. I'm a New Zealand registered dietitian and I have the privilege to speak to you today about some of the mahi I've been doing in my role at the Heart Foundation. The Heart Foundation is a New Zealand heart charity and is dedicated to improving heart health and reducing the impacts of heart disease through education, research and support. With a focus on prevention, the Heart Foundation works to empower individuals and communities to make heart-healthy choices for a healthier future. This session will provide you with an understanding of one of our flagship programs in early learning services and how what we are doing today is paying it forward for tamariki tomorrow. So firstly, I'll provide you with a bit of a background on the program and the aim of the research. I'll then spend some time providing you with an overview of the methods and results. And finally, we'll end with some insights into the limitations of the mahi and next steps. So we know indicators for long-term risk of heart disease are already measurable in childhood, and establishing childhood heart-healthy routines has been shown to track into adulthood. So the Heart Foundation is proudly committed to delivering impactful programs for tamariki. The Tohu Manawa Ora Healthy Heart Award program has been implemented since 2002 in early learning services nationwide. The colour-filled poster on the slide depicts the aims and scope of the program, where happy tamariki grow an awareness of how to have hearts fit for life, ensuring healthier futures for whānau across Aotearoa, New Zealand. It achieves this through sustainable change to the environment by using a whole-of-service approach, mirrored by action areas in the World Health Organization Ottawa Charter of Health Promotion. The program embraces cultural diversity, community environments, and whānau realities. Governance and management, learning and teaching, collaboration and professional development are key components of the program and make up the 7 strands listed on the slide. The program includes in-person and online support from a nutrition advisor all across the motu. It provides access to resources, sample guides and policies, plus professional development for kaiako and cooks. Collaboration with whānau is key, alongside lesson ideas for kaiako to deliver to tamariki. When early learning services meet the framework criteria for a particular level, they earn an award that is valid for 2 years. So RITO is the founding award and ensures services meet the Ministry of Education licensing criteria, which is relevant to the program, and the Ministry of Health guidance. whānau, the second award, is built upon the foundations of RITO, and it helps build and strengthen existing healthy eating practices and physical activity practices. Tahara Kehi is the highest award and recognises a wellbeing focused, sustainable and established practice. So over the time, the program has undergone several evaluations. It has been over 20 years, quality improvement reviews and consumer insights gathering. Engagement data and quality of the intervention are monitored as part of the program structure, and the quality and the fidelity of the program is strong and sits beside other early learning service programs internationally with a wide evidence base supporting the approach. So from this research, we wanted to understand and monitor our impact, improve our decision-making by utilising data and insights, and communicate the impact of our work to stakeholders in a compelling way. So our research aim was to evaluate and understand the impact and social value of the program on fostering healthy habits and creating supportive environments in early learning services across Aotearoa, New Zealand. So the Heart Foundation engaged an external supplier, Impact Lab, to help measure the social value of the Tohu Manawa Ora Healthy Heart Award program. So as you can see from the diagram, throughout our lives, different events occur, such as trauma, achievement, health challenges, and they all impact our overall wellbeing journey. Social value is the estimate of the social impact in dollar terms that a program achieves for participants over their lifetime by changing their wellbeing journey. To calculate social value, we combine the impact values, both positive benefits, such as increased income and avoided cost to government. With this, we look at the evidence from the global literature about how effective a program can be, the size of the opportunity for the people served, and the number of people supported. We then combine these inputs and put them into the social value calculation. Once we have the social value, we can look at the social return on investment by dividing that by the cost of the program. So over 6 months, we went on a journey with Impact Lab and defined our scope as the year of 2023. We considered our reach to be for tamariki, but we also wanted to look at our impact potentially for whānau and kaiako. Our engagement was defined as services who had at least a RITO award or were enrolled and held a whānau or Paharakiki award. We excluded services that were on the journey to achieve a RITO award because we weren't sure where they were at in their journey. We provided, I'm not sure why it's jumping. We provided extensive program data, including the number of people we work with, the demographics, the costs associated with the program, and the activities delivered. So an impact logic was built, and at the same time, a rapid literature review and a social return on investment analysis. And so what we found was the evaluation affirmed that the social return on investment was directly contributing to the improved physical activity and oral health and reduced diabetes for tamariki. In addition, there was also contributing to increased physical activity for whānau. There was also some indirect links to improved health equity, improved nutrition, increased food exposure, promoting lifelong well-being, reducing cardiovascular disease, and reducing sugar consumption. So for the 2023 year, we were measuring the outcomes for 33,000 tamariki who had been enrolled in the service. And by the end of that year, 20,000 of those had been in the service for the whole time and completed the award. The demographic breakdown is up on the pie chart there, where we have 38% Pakeha, 20% Asian, 18% Māori, and 6% Pacifica. So what impact are we having in dollar terms? So for every dollar invested, a good social value is about $2. But for the Tohu Manawa Ora Healthy Heart Award program, we saw a return of $4.50, which is a 450% return. So we're pretty stoked with that. So if I just go on and explain it a little bit. So if we come back to the social value explanation, it's obvious that the greater distress or trauma that happens in your wellbeing journey, the greater potential social value you have to gain. And this is why we see some programs in recovery space having significant social values. We knew that early establishment of healthy habits would track into adulthood, but what we didn't know was how to articulate how much these habits would support the tamariki and contribute to the social impact. We can now confidently say that by creating supportive environments for healthy habits to flourish through the Tohu Manawa Ora Healthy Heart Award program, we have a significant social impact. We can expect to contribute to physical activity, oral health, reduced diabetes. And we can also contribute to health equity, nutrition, increased food exposure, promoting lifelong well-being, reducing cardiovascular disease and sugar consumption. And for every investment in the resource, we're expecting to see a 450% return in social benefit. So this nicely aligns to the age-old saying that if you give a man a fish for a day, you will feed him, but if you teach him to fish, he will eat for a lifetime. There's always limitations of the mahi, so I'd like to highlight the following. The previous methodology that Impact Lab has been using did include cardiovascular disease, but this outcome measure was outdated and so was excluded from this research. So going forward in future methodologies, if we were to do this again, we would include that cardiovascular outcome, and that means that there's probably value left on the table for us to look at where we might be adding more. We also know that we were using a static role from the Ministry of Education, and in early learning services, there's a lot of natural fluctuations in the role, and that can be from enrolments, graduates, sick days, and part-time enrolments. We also are aware that the impact that we had on Kayako wasn't captured, and that's due to the lack of attributable data. So we'll be working on ensuring that the data that we are setting out to collect actually captures the impact of the program on those Kayako, not just on the children. We didn't measure the impact of engagements in services who weren't signed up to the award. And this is tricky because these are often the most complex services. They often have the most to gain, and we work with these services in a really different way. It's much less structured, so we're able to meet their needs. And the other, I guess, limitation to consider is that we chose to conservatively estimate the number of whānau influenced by the program. So we're looking forward to continuing to pay it forward and investing in tamariki and early learning services. And the evaluation has been really compelling. We'd like to measure more of our work and broaden our reach. And one obvious area to improve is the program's components, which can impact kayako and whānau. So if anyone would like to see the full report, they can email me. Otherwise, that's me done. Thank you.
Thank you, Frances. I found that very, very interesting. I'm quite impressed. It's very impressive. The return of 450% return on your value. That's pretty impressive. I haven't seen anything like that for a long time. I thought you explained terms and ideas and limitations very simply and clearly, so that was really good. And I enjoyed the graphics on your presentation, and that's a good example behind you. So it must run in your office, that glass wall behind you, or the graphics that you've done. Thank you very much for presenting to us today, and we're almost back on time. So Is that a question I see in there in the Q&A?
There is just one quite brief question from Hilary, who asks, were the outcomes measured or modelled?
They were modelled of the literature, yeah. So given the discussions that we were having earlier this morning, it made me think, oh, I need to go back and look at all those references. But yeah, they were modelled.
All right, I don't see any more questions coming through, so I think we can move on to the final presentation.
Okay. I always get a bit lost here because I can't see Giles up on the top. Here he is. I'd like to welcome back Giles Graham from the Environmental Science and Research Institute. His topic, our last topic for this afternoon, is the ARI Surveillance, mistakes and lessons learned from maintaining the ARI Surveillance dashboard. His work interests include system and process improvements, flu tracking, the use of R to enhance surveillance analysis practice, and increasing team bicultural competency. Outside of work, his interests include reading, writing, and mathematics. Welcome, Giles.
Kia ora, Peter. Now, a very quick administrative note. I'll just while I'm giving the introduction, I'd just like to double check that my co-presenters do have the ability to unmute when the time comes.
Yes, we do.
Yep, wonderful. Okay. Oh, great. Kia ora kouroa, great to see you. Oh. E hara taku toa I te toa takitahi, e kari he toa takitini. Kia ora koutou, he mihi anō ki te atua o te raki, mō te oro o te iwi ao, tēnā koe. He mihi anō kia koutou Barry Bilmer, Peter Himona me ētahi atu tākata, nā koutou I whakahaere tēnei hui, tēnā koutou. He mihi anō ki ētahi kai kōrero mō te marama tako hoki, tēnā koutou. A muri a tērā, he mihi kia koutou katoa. Ko wai mātou, he kai tātari tā mātou mahi mō ESR, ko Andy Engelmeyer, ko Zoe Kumbaroff, ko Giles Graham mātou. Nō reira, tēnā koutou, he mihi kia koutou katoa. So, my name is Giles Graham, and I'm back, this time facilitating a talk about the respiratory illness dashboard, specifically some challenges we've faced and things that we think you could learn, and some things that we have learned and that we think you would find useful as well. So Zoe will take over soon to explain the process of updating our dashboard each week. Then I'll share about some learnings from within the analysis scripts themselves, and Andy will take us out with a discussion on some of the nuances of surveillance data and what can get lost in analyses. So without further ado, Zoe, over to you.
Thank you, Giles. Kia ora koutou, ko Zoe Kumbaroff aho. I'm an epidemiology analyst at ASR and part of the team who updates the acute respiratory illness infection, or ARI dashboard. So the ARI dashboard is found on our website, but you can also find it just by Googling ARI ASR dashboard. I'll just quickly summarize the dashboard for those of you who are unfamiliar with it, and then I'll just briefly run you through the process for updating the dashboard. So the ARI dashboard presents multiple systems that are in place for ARI surveillance and gives us a picture of respiratory infection burden in hospitals and communities in New Zealand. The dashboard is organized into tabs, which you can see across the top of the image there. So for example, we've got the hospitalization tab, and this summarizes data that comes from our severe acute respiratory infection surveillance in 2 Auckland hospitals. And it will show us weekly rates, and then weekly rates that are for influenza only and for COVID-19 only. We've also got the community tab, and this has rates for healthline calls that are related to influenza-like illness, and also trends for flu tracking, which is a kind of like a survey of participants that indicate whether they've had flu-like illness or COVID or influenza vaccinations in the last week. There's also other tabs related to virology results and breakdowns by demographics, so by age and ethnicity. Across the dashboard, we've also got commentary that helps you to interpret the figures, and you're able to filter and highlight the figures for easier viewing of the data. So the process. During winter, our dashboard is updated weekly on a Thursday generally. We use surveillance weeks that run from a Monday to a Sunday. So when we update on a Thursday, the most recent data will be for the previous Sunday. On a good week, all the data has arrived by the end of the day on Wednesday, and it's all been checked and any issues have been sorted out before we log off on a Wednesday. And then on a Thursday morning, we run some R scripts, and there's some automatic updates, and these allow us to view a sort of draft version of the dashboard that's available only internally. And with this, we can write commentary. So this is written and then peer reviewed, and then it is reviewed and signed off by a technical lead and a public health physician. We then let our data and informatics team know that everything is ready, and they publish the dashboard to the website, and we do a final check of the live version. So it all sounds pretty easy and straightforward, and it can be, but sometimes it can get a little bit hectic. A typical Thursday involves a number of other tasks, most of which have designated R scripts, potentially other data sources and other people involved. Some of these tasks are the FluNet update. So this is through the WHO, and we run a script basically that updates a spreadsheet that then also needs to be checked. And this is uploaded to a portal. We then run some other scripts for ad hoc analyses, which are mostly to monitor any emerging trends. So something of concern recently has been different virology results by age. Another script that summarizes ARI outbreaks that are reported to EpiServe. This is also included on the national summary page of the dashboard. And then we constantly have communications between the Epi team and the data informatics team about issues and improvements and just status updating and checking in throughout the day. So there's lots of things involved in this dashboard, and generally everything runs smoothly, but there are lots of points where things can go wrong and will go wrong. But we try to learn from these issues and use them as opportunities to enhance our processes. So hopefully that's given you a little more understanding of the ARI dashboard. I'll pass you back to Giles now, and he will tell you some specific dashboard related issues that we've encountered. Thank you.
Kia ora, Zoe. Thank you so much for running us through some of the background of that and what kind of goes into producing the dashboard. So yeah, I will be taking over again now to, I'll be covering firstly, just a quick note about these next two kind of points that we look at. They both happen to do with SARI. I wanted to disclaim that it's not that we don't have challenges and interesting lessons from some of our other systems. It just so happens that the lessons here we found particularly interesting and with implications for how systems can operate. So we thought it had the most learning potential. So this tale starts in that first section of the day when Zoe runs the scripts. Now, many of our scripts are already automated, but for various legitimate reasons, our SARI is one that we still initiate manually. A few years ago, we had an issue where one part of our script was taking too long to run. There are two parts to this problem. The first is computational complexity. You may have heard of big O notation or big O complexity or time complexity. They're all about the relationship between how big your input is and how long it takes your program to run. Without explaining all the types, the scale runs from one end of great, where it doesn't matter how big your input is, through a linear relationship relationship between input size and runtime, through to some of the worst cases, we might have exponential growth on your runtime as your program input gets longer. Now, in SARI, we don't use a moving window of analysis. So we might be covering anywhere from a month to a year or two in our current analysis pipeline before we move a block into our historic longitudinal data set. And so over time, our input gets bigger. Specifically to this case, we were dealing with a thing called fuzzy joins, the other part of the problem. Now, fuzzy join is because here we were wanting to join on NHI and admission date, but we know that between the two data sets, the dates will not exactly match. There'll be up to a few days difference between the date in one set and the date in its matching row in the other set. We need to accommodate that when joining up the two data sets, and hence the fuzzy join function. It's a pre-made function that takes care of that whole issue for us, but at the cost of exponential computational complexity. So it was taking longer and longer for the script to run. Sometimes it would take over an hour. Sometimes it would overrun the memory entirely and crash. We solved the issue this time by mapping out the decisions and steps that we actually wanted to take when doing our fuzzy join, and then just coding that out explicitly in the script. And it solved for us two problems, actually. First, of course, the issue of runtime. It went from over an hour to less than 5 seconds. I didn't time it exactly, but I know it went from being a huge burden in our workflow to being unnoticed. The cause of that was our pre-made function was generic. It could handle all sorts of fuzzy joining, but at the cost of efficiency. We could take advantage of the specifics of our problem to save a lot of computational time. The other bonus was improved clarity of our script. It made explicit decisions that were previously implicit and hidden in the fuzzy join function. And that's really good because we consider the script significant as a piece of the larger documentation in addition to production code. And so while we gained about 60 or 70 lines of code to clearly articulate the join process, we gained time and we gained readability. The second example of this happened during this year. It was, and it's in this small section of code here in the middle. Now that's a pattern that comes up another 1 or 2 times in the script. And at this point, we have done a refactor of the analysis process. So the script looks significantly different than it did a few years ago. And this is normal. We'll have to do this again in the future. As long as our scripts interact with the real world, which is changing, we will need to change them accordingly. When we initially wrote this pattern into the script, it wasn't actually slow. But week by week, it took just a little bit longer to run until it was taking about 45 minutes. It felt a little bit like that adage of putting a frog in a pot of water and slowly heating it up. It just kind of crept up on us. Now, the analyst who was running the scripts at the time was handling this, but if they had to run the script again for whatever reason, or when we were trying to make some other improvements or amendments, it was really frustrating to have to wait for it all to run. It was a real inconvenience. So some situations, this is unavoidable, but this isn't a situation where we have to make do. So we did go again and fix it. The change this time, it was more about the fundamental limits of our particular programming architecture. Sorry, it's a little bit of a weird technical term. Generally in our team, we use a thing called the Tidyverse suite of R packages. That's the R programming language. And the Tidyverse suite in its vernacular is really good for readability of your code. But sometimes it's not so good for performance. Instead, we used in this particular section the data table package, which I do recommend if you are looking for something that is really, if you're really looking for efficiency and quick runtimes, it is built for speed. And we found that we went from 45 minutes to about half a second. Again, I didn't run the numbers strictly. There was more of a cost this time, though, in reduced clarity of our script. Now all analysts in the space have to have some understanding of the data table package and how it works just for this one section. And it works and it looks significantly different to our kind of tidyverse vocabulary. We use R in a team, but across the team there is varying levels of experience and capability. We're all on a journey of upskilling, and in this and beyond, it's preeminent that we keep our code readable and understandable. Almost more important than whether we can run the code is whether our teammates can read it, debug it, improve it, and reuse it. And so we don't take these decisions lightly, as they limit the reusability and comprehension of the code. Now remember, we consider our code a genuine part, not the whole, but a part of the documentation process. Now, what will we do the next time we hit a complexity issue? Should the script get more and more complex? Well, at some point, it's no longer going to be the domain of epi analysts to reasonably handle and maintain this code. It will no longer be our expertise. Now, I mentioned earlier that many of the scripts are already automated and that that's not handled by us. So I also referenced the data and informatics team. They are amazing. They handle so much of the automation. They are responsible for getting so much of the analysis onto the dashboards. They handle the digital architecture of our data and of our surveillance systems, and it's their expertise. I'm really grateful for all the work they do and how it allows us as analysts to do our work. It's important for any organization to know when it's a good time to make that switch, when it's better to hand a particular task to a dedicated team and to free up your analysts to work within their expertise. So for this last section, I'll hand over to Andy to discuss the focus of the talk, which is testing our definitions. Over to you, Andy.
Kia ora. Thanks, Giles. Hi, I'm Andy Engelmeyer. I'm an epidemiologist, also a DSR. And I'll just a couple minutes here just to give you an example of something that popped up recently in the last couple of years with our sorry again is the severe acute respiratory illness or infection surveillance system that takes that we have collected these data since 2012. And so we have these patients that are hospitalized in the Auckland area. We are able to enumerate all of them. And for nearly all of them, probably around 97% or so, we have their virology. So their virology data we get from the hospital labs themselves. But so you know, in theory it sounds like, well, that's great. So you have hospitalizations, you have virology, you should be able to sort of pretty easily establish what the most common pathogens are that are making people sick. And also a really important aspect of that is establishing sort of test positivity rates. And so as most of us probably know, especially during the COVID times, we were, early COVID days, we were looking at sort of test positivity to see whether we were sort of trending up or trending down in terms of infection burden in the community. And while we can actually calculate something like that with regards to influenza-like illness with SARI data, it's not as straightforward. And so I'm going to give you an example. So we have essentially three possible units of analysis with our data, right? We have the test, we have the hospitalization itself, and we have the person, the unique person. Now, there are these patients who are, quote, as the nurses refer to them, frequent flyers. Frequent flyers are patients who are unfortunately frequently hospitalized for a number of things. So if they are frequent flyers, then they have multiple hospitalizations. So the same person can have multiple hospitalized more than once. In fact, the same person can be hospitalized more than once in the same week, in theory. So, and for each hospitalization, they can have multiple tests. So, for example, when a patient is given a panel for respiratory pathogens, usually that panel will be a short panel, including the big three: COVID, RSV, and influenza. All right, so if they test negative on all three of them, and the clinician is still interested to figure out whether they are positive or something else, like metapneumovirus or parainfluenza virus or rhinovirus for that matter, there's a broader panel, which is often used as well. But that broader panel also includes the big three: COVID, RSV, and influenza. So now we have the same hospitalization for the same patient being tested twice now for influenza, RSV, and COVID, and once for pneumovirus and so on. So we have to figure out how to handle that. If we want to get test positivity for any one of those pathogens, we got to figure out a way to do it. And so our solution was really essentially just to collapse all test results for each hospitalization, not for individuals, but for the hospitalization. So if they've had 4 tests for COVID and all of them are negative, then that hospitalization was negative for COVID. If they've had 3 tests for RSV and 2 of them were negative and 1 was positive, then collapsing them, we default to the highest or the most positive, and we find that during that hospitalization, they were positive for RSV. And that's essentially how we get a test positivity rate for our pathogens, usually for influenza, RSV, and COVID sometimes are the big 3 that we look at. Now, on our dashboard that Zoe was talking about, we actually display hospitalization rate due to influenza. So again, the unit of analysis is hospitalization, not the actual individual patient. So that's just an important factor. Giles, next slide. And so again, our solution, by collapsing all these tests for each individual hospitalization, our test positivity is a reflection of any positive test during the hospitalization. It's not a positivity rate that you would normally get by, looking at the total number of tests in a community. Say during our early days of COVID, we were really concerned about test positivity. So we had all of these tests and say 9% came back positive. Our test positivity rate would be 9%. In this case, it's a little bit different. It's not really generalizable, but our positivity definition, as you can see, is really limited to or collapsed by hospitalization. Anyway, so this was just an example of something that has come up when we are trying to interpret our trends in ILI, specifically for SARI. It often comes up that, what's the number of hospitalizations? Well, it's not as easy, or the number of patients, it's not as easily answered straight from our dashboard, for example. And we oftentimes forget that we have, again, these 3 units of analysis. And as long as we remind ourselves, so that we can remind the public, that when we look at our data, it's really by hospitalization, not by the person, or even by that, for that matter, by the test, then hopefully our interpretations are correct. So thank you.
Kia ora, thank you, Andy. And thank you all for listening today. So we have shared some hard ones that you find some of it useful in your own work. Ko mutua te pānui. Mā te wā.
Tēnā koe Giles koutou, ko Zoe, ko Andy ngā mihi ki a koutou, ka tahi te kōrero, te ngāhau, te mārama. Thank you, Giles, Zoe, and Andy. I found that very enlightening and insightful on how to run a dashboard. I have to admit that I'm not a programmer, and if I go anywhere near that, sends waves of alarm through my team. But what I can say is that I did understand all the terms that you talked about, and you explained them very well. I knew what you were doing. I don't know how you do it, but I knew what you're doing. So thank you for that. I found it very enlightening. Thanks. I see that there was a question before, Patrick. It seems that
Charles has actually answered it in the chat, so it's taken care of.
Oh, okay. Are there any other questions?
No, there are none.
Well, once again, Giles, Zoe, and Andy, thank you very much for presenting us this to us this afternoon. Did the panel, anybody else have any comments? Okay, so it's, thank you for today. I really enjoyed this morning and this afternoon. We all now know what paper mills are. I didn't quite understand that term. We all know to look out for our dodgy papers now when we do our analysis. Then in the next session, we had Tales from the Frontline. Those are very interesting talks on what people have experienced. Then this afternoon, we had James, Lynn, Kaaren, Bernadine, and Francis, and the group just now, all very interesting and quite a full day. I must apologise for pushing everybody through a bit quicker this afternoon, but we're not far off we might even be on time now. So how about that? Does anybody have any comments? Otherwise, it's pretty well closing time.
Peter, I'd just like to thank all the presenters like you did, and also the chairs, you and Tim, and also Patrick for his work as well. So thank you, everyone.
Okay, well, that's us for today. I wish everybody the rest for the remainder of the day and a safe return to their families and homes. We'll close off now with the karakia. Kia tau, kia tātou katoa, te atawhai o tō tātou āreki o heu karaiti, me te aro o te atua, me te whiwhinga taitanga, i te wairua tapu, ake, amene. Thank you all.